ꯎꯏ ꯁꯥꯔ
ꯎꯔꯦꯀꯣ
ꯎꯝ
ꯎꯗꯦ ꯍꯥꯏꯔꯕ
ꯎꯏꯌꯦ
ꯎꯏꯌꯦ ꯑꯣ ꯌꯥꯔꯦ
ꯑꯧ
ꯀꯣꯏꯁꯟ ꯅꯝꯕꯔ 1 ꯁ꯭ꯇꯥꯔꯠ ꯇꯧꯔꯁꯤ ꯁꯤꯗ ꯂꯩꯔꯤꯁꯦ ꯀꯣꯏꯁꯟ ꯅꯝꯕꯔ 1 ꯁꯤꯗ ꯑꯍꯥꯟꯕꯗ ꯑꯣꯞꯇꯤꯛꯁꯁꯤ ꯇꯝꯗꯣꯏꯁꯦ ꯔꯤꯐ꯭ꯂꯦꯛꯁꯟ ꯖꯨꯝ ꯇꯧꯒꯦꯀꯣ ꯔꯤꯐ꯭ꯂꯦꯛꯁꯟ ꯔꯤꯐ꯭ꯔꯥꯛꯁꯟ ꯃꯊꯪꯗ ꯗꯤꯁꯄꯔꯁꯟ ꯁꯤ ꯑꯍꯨꯝꯁꯤꯅꯤ ꯃꯦꯟ ꯑꯣꯏꯅ ꯇꯝꯗꯣꯏꯁꯦ ꯀꯩꯅꯣ ꯔꯦ ꯑꯣꯞꯇꯤꯛꯁꯇ ꯀꯣ ꯑꯗꯨꯗ ꯌꯦꯡꯉꯣ ꯔꯤꯐ꯭ꯂꯦꯛꯁꯟꯁꯤꯗ ꯃꯈꯜ ꯑꯅꯤ ꯇꯝꯃꯛꯀꯅꯤ ꯍꯤꯌꯔ ꯔꯤꯐ꯭ꯂꯦꯛꯁꯟ ꯋꯤꯜ ꯕꯤ ꯁ꯭ꯇꯗꯤed ꯏꯟ two defined category. Number one will be reflection through plane mirror, and number two will be through spherical mirror. Can you see the formula? ꯐꯣꯔꯃꯨꯂꯥꯁꯦ ꯎꯕ ꯉꯝꯕ꯭ꯔꯥ ꯈꯔ ꯖꯨꯝ ꯇꯧꯊꯣꯔꯛꯎꯔꯥ
ꯑꯧ ꯑꯧ
ꯁꯤ ꯐꯣꯔꯃꯨꯂꯥꯁꯦ ꯎꯔꯦꯀꯣ ꯁꯤꯗ ꯐꯣꯔꯃꯨꯂꯥꯁꯤꯗ ꯍꯥꯏꯐꯦꯠ ꯆꯥꯎꯔꯥꯛꯄ ꯑꯃ ꯇꯧꯔꯝꯁꯦ ꯑꯗꯨꯒ ꯖꯔ ꯖꯔ ꯁꯝꯖꯤꯟꯁꯦ ꯅꯪꯅ ꯈꯪꯒꯗꯧꯕꯁꯦ ꯑꯩ ꯁꯨ ꯅꯣꯠ ꯗꯤꯁ ꯚꯔꯆꯨꯋꯦꯜ ꯕꯦꯛ ꯍꯥꯏꯇꯥꯔꯗꯤ ꯏꯐ ꯗꯤꯁ ꯚꯔꯆꯨꯋꯦꯜ ꯋꯥꯔꯗꯁꯦ ꯋꯥꯔꯗꯤꯡꯁꯦ ꯚꯔꯆꯨꯋꯦꯜ ꯍꯥꯏꯅ ꯂꯥꯛꯇꯥꯔꯗꯤ ꯑꯣꯕꯖꯦꯛ ꯑꯣꯏꯔꯒꯅ ꯑꯣꯕꯖꯦꯛ ꯃꯁ ꯕꯤ ꯕꯤꯍꯥꯏꯟ ꯑꯗ ꯏꯃꯦꯖ ꯑꯣꯏꯔꯒꯅ ꯏꯃꯦꯖ ꯃꯁ ꯕꯤ ꯕꯤꯍꯥꯏꯟ ꯑꯣꯏꯒꯗꯕ ꯑꯩ ꯍꯥꯏꯁꯦ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧ ꯉꯝꯕ꯭ꯔꯣ ꯌꯥꯏꯀꯣ virtual means kaiba virtual object means it will be behind the object and what about the virtual image will be behind the mirror image hamati ko behind the mirror oigadaba ado real hai taradi whatever nang image to reju image will be in front or object must be in front so we can broadly classify image into two category number one will be real image which will be formed in front of the mirror and what about the virtual image will always form in the background or behind how do you call behind the mirror the form tokta it will be nangi virtual image and haigani real gi tare for real image or real object they must have they must be placed before the mirror ꯗꯨꯒꯤ ꯃꯃꯥꯡꯗ ꯂꯩꯒꯅꯦꯕ ꯑꯗꯨꯒ plane mirror ꯗ ꯑꯣꯏꯔꯁꯨ ꯌꯥꯏ ꯅꯠꯇ꯭ꯔꯒ spherical mirror ꯗ ꯑꯣꯏꯔꯁꯨ ꯌꯥꯏ irrespective of the type ꯅꯪꯒꯤ type ꯇꯣ plane ꯑꯣꯏꯒꯦꯔꯥ spherical ꯑꯣꯏꯒꯦꯔꯥ real image or real object must be in front real ꯍꯥꯏꯕ ꯋꯥꯍꯩꯁꯦ this real will always come in front of the mirror understood ꯇꯧꯔꯦ ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨꯗꯤ ꯗ next ꯑꯃꯨꯛ ꯂꯥꯛꯑꯣ plane mirror ꯁꯤ ꯇꯧꯔꯁꯤꯀꯣ here plane mirror ꯁꯤꯗ ꯂꯩꯔꯤꯁꯦ ꯀꯔꯝ ꯀꯔꯝꯕ ꯀꯟꯗꯤꯁꯟꯅꯣ ꯁꯤꯗ ꯂꯩꯕꯁꯤ ꯀꯔꯤꯒꯨꯝꯕ ꯑꯣꯕꯖꯦꯛ ꯑꯃꯁꯦ at a distance x ꯊꯝ ꯇꯥꯔꯗꯤ where will be the image will be formed at the same distance behind the mirror ꯗꯨꯒꯤ behind the form ꯇꯧꯒꯅꯤ understood ꯇꯧꯏꯀꯣ and there will be left right alternation ꯍꯥꯏꯗꯤ ꯑꯣ ꯌꯦꯠ ꯑꯣꯟꯅꯒꯅꯤꯀꯣ and ꯑꯩꯈꯣꯏꯅ ꯁꯨꯃꯥꯏꯅ ꯈꯜꯂꯁꯤ ꯃꯤꯃꯤꯠ ꯇꯥꯔꯤꯕ꯭ꯔꯥ ꯑꯩ ꯍꯥꯏꯁꯦ
ꯇꯥꯏꯌꯦ ꯁꯥꯔ
ꯑꯗꯨ ꯁꯤꯗ ꯃꯤꯔꯔ ꯑꯃ ꯂꯩꯔꯦꯀꯣ ꯁꯤꯒꯤ ꯃꯤꯔꯔꯁꯤꯗ ꯁꯤ ꯂꯥꯛꯏꯕ ꯔꯦꯁꯤ ꯀꯩ ꯀꯧꯏ ꯗꯤꯁ ꯋꯤꯜ ꯕꯤ ꯏꯟꯁꯤꯗꯦꯟ ꯁꯤꯅ ꯀꯩ ꯀꯧꯅꯤ ꯗꯤꯁ ꯋꯤꯜ ꯕꯤ ꯔꯤꯐ꯭ꯂꯦꯛꯇꯦꯠ ꯑꯁꯤꯗ ꯂꯩꯕꯁꯤ ꯀꯩꯅꯣ ꯏꯟꯁꯤꯗꯦꯟ ꯔꯦ ꯑꯦꯟ ꯗ ꯔꯤꯐ꯭ꯂꯦꯛꯇꯦꯠ ꯔꯦ ꯍꯦꯞ ꯑꯦ ꯀꯃꯟ ꯀꯔꯤꯒꯗꯣꯏꯅꯣ ꯄꯣꯏꯟ ꯗꯤꯁ ꯀꯃꯟ ꯄꯣꯏꯟꯁꯦ ꯗꯤꯁ ꯁꯇ꯭ꯔꯥꯏꯀꯤꯡ ꯄꯣꯏꯟ ꯏꯁ ꯅꯣꯟ ꯑꯦꯁ ꯅꯣꯔꯃꯦꯜ ꯑꯁꯤ ꯅꯣꯔꯃꯦꯜ ꯑꯃ ꯂꯥꯛꯄ꯭ꯔꯥ ꯄꯣꯏꯟ ꯑꯣꯐ ꯏꯟꯁꯤꯗꯦꯟꯁ ꯀꯧꯔꯅꯤ if a perpendicular is drawn if a line is drawn perpendicular to the reflecting surface then this perpendicular will be known as normal ama kaudi natra adudi we know that from law of reflection angle of incidence will be equal to angle of reflection aduga magi deviation haidini ko delta means it is the deviation haibadi magi original party sumai lak natra original part is like this sumai lak pasida it is deviated due to kana hoidino due to reflection sida maram oraga magi path to change tawi ko aduidi how much of angle is changed haitaragadi. Here we know that from our law of reflection, angle of incidence is equal to angle of reflection. Altogether this is a straight line. Straight line ama tabni 180 lani ko 180 minus we can put it as minus 2i. Then si books kya hoga, from here to here this will be 2i. Okay, and after that we will be having 180 minus 2i as the angle of deviation. Yadra yara understood tawre ko sima khange. Next tamu yango, this is very important. Sima maru hoy ko nangi number of images formed by a two plane mirror inclined at angle theta. Select this here we have to find out this 360 divided by theta. Sibu khoi na kai ko with this is nothing but it is the number of rotation ko kane. Number of rotation hana find out toro. Number of rotation je kaino 360 divided by theta. Aduga minus 1 am lakpra. Minus 1. Aduga kari karama matamda minus 1 je hakoni. We will be using this formula if 360 divided by theta comes out to be even. If you do not understand this, then I will illustrate here. This is angle 30. Angle 30 am lebanatra. Next time this is rotated in this direction by angle 30. This is angle 30 rotation to abra. Sidung 30 yung rotation to abra. Sidung 30 rotation to ko. All together kya legani se then the 360 m later bro. If 360 is divided by this 30, then what will be the number of rotation? Number of rotation will be 12. Okay. Adugo cham manana kamai organi. If this is theta, there will be also another theta over here. Adu the all together kala ani number of rotation will be 360 divided by theta. Understood to ngamda ngamiko. Adu di nang na ahan bada number of image from calculate the height d. You have to first find out the number of rotation. If the number of rotation comes out to be even hoita radi, what will be the number of image formed by see mirror sina. This is plane mirror abdi it is looking mirror niko. Looking mirrors gi size the nan object ma thame kalaji a habam thame a zigi image kya form to bani. If this theta is equal to 30 degree होता रदी नंगे answer will be number of image will be क्या तागनी number of image will be 11 तागदी understood तो बता 12 minus क्या original 12 minus 1 that is 11 understood तो रे haygadra hayroidro hayrani ko adudi how will you find out the number of image between two plane mirror inclined angle theta. It is very simple. First of all you have to find out the number of rotation, and if the number of rotation comes out to be even, then the number of image form will be equal to number of rotation minus 1. Understood tawre ko even hoitadi minus 1 hogadaba. And next time nang na log duise kailani if 360 if 360 divided by theta, that is number of rotation comes out to be odd, then there will be two possibility any laigani ko. Possibility and is kind of when the object is placed symmetrically to the to incline plane mirror and is the symmetrical in my angle bisector tham tar you are going to use the same formula number of rotation minus 1 adu asymmetrical habadi kaino if these two angle are not equal, this is alpha, this is beta. Gyan tayo ko, object is symmetrically on a locate of the tare kalazi. Then what will be the answer? The answer will be only number of rotation ka manarani. Ang tanga hierarchy, do you want me to repeat this or not? Yadra?
Oh, yani jadi.
Yarani ko, khangi ko. Aduga next number sida haris na kayo plane mirror magidi nang na sida 4 meter per second sida run tawre kalazi ko towards the mirror. Adudi nang object to kaya dalay object to behind object to na in front lay ko adu si kayo gani this is real tagadra taroidra image ti kaya dalay image will be behind or na this will be virtual with na tro understood to mga mi adu itad here kay kari kang mga mi. We know that plane mirror will always form virtual image. Virtual image form tawani and when this object is coming or when the object is moving towards the mirror with some speed, then this virtual image will also move towards the mirror in the towards the mirror with the same speed 4 meter per second. Gyan tabra behind the ma 4 meter per second ma so ai chenjala kane understood to bongam brangam da bro ngamme khangani ko hari ja yarani aduga nang khangadubje remember that for virtual there will be a loss kayugani image formation behind the mirror to behind the form to gane nang na sona kadam chathok putadi if you run away from the mirror then image will also uh, move away from the mirror behind the behind je mirror gi behind the majo run away to gine yagadra arani sima khange ko this is not so much important see important with the what is important one what is important is our spherical mirror. Spherical mirror se hanadi concept lebra. Do you have earlier concept of this spherical mirror? Can I go can I briefly explain it? Yam tena na explain to ya bra natraga detail da khara haiba pamra
Detailed ꯍꯥꯏꯕꯤꯌꯨ
khara detailing pamebako
ꯑꯥꯎ
ai aji sida ma yengasi ko spherical mirror haitardi kaino why this is called spherical mirror because this is being carved out or this is being taken out from a sphere if this is cut over here si cut tawtaradi kaino we have nangi karama jaga am phangani we have a hemisphere just like bowl akogi rice ka chana ba koina soup ka thangna ba bowl to adugi mongdom laigera tengkot mala laine gyan tai ko it will have one cup surface a two cup surface ani laigani ko one will be inner and another will be outer adudi kayubase if the inner surface if the inner surface is silver taisaleta andi kedorani the extruded id tongthok pa id natra aduga koi physics ki language le masi kari hai convex hai gani tongthok pa taragadi extruded portion ji koina convex hai adu sida karigumba if the reflection takes place in the convex side it will be known as convex mirror kogane is there understood or not yani ko next time kay obitara instead of silvering in the concave side koina sigi extruded portion sida silver tawre then magi reflection from the phone the reflection will take place in the concave side concave hairgana magi kuchan ba depress to sina depress habi natra depress edi kuchan ba habi natro depress to region sida oiragana if the reflection takes place uh, along the depress or concave side then it will be known as concave mirror amogene yagada yaroida yarani ko now let us go directly to our image formation da mu yengasi demo my form labudi chidale reko this is compact on evening anyway there will be two types number one the kai lakane absa number one the concave fibum lakni ko concave mirror this is very important concave mirror se amaru ko most of the question will be based on concave mirror why okay you know concave mirror can form both real image real and virtual mana form to bunga me adi what is the basic difference between real image and the virtual image other than that other than the location magi location di ko na kange ko real image kara legani real image will form in front of the mirror and what about the virtual image will form behind the mirror natra simple way khange adu nataba what is the basic difference the basic difference is that real image can be produced on a screen just like koina cinema hall da yeng matamda picture do screen amada taba ngamidra that is real image understood tawi and virtual image hai tadi kaino virtual image means it cannot be produced on a screen da produce to bungam de yabra yai ko ai hai khangmungami adudi we can clearly say that concave mirror has the ability to produce both real image and virtual image therefore this is very important number 1 da hani ngasi ko ꯑꯩꯒꯤ ꯃꯥꯒꯤ ꯇꯦꯛꯅꯤꯀꯦꯜ ꯇꯥꯝꯁꯤꯗꯗꯤ ꯑꯩ ꯌꯥꯝ ꯏꯟ ꯗꯦꯞꯇ ꯆꯠꯂꯔꯣꯏꯒꯦ ꯖꯁ ꯋꯥꯠ ꯏꯁ ꯔꯦꯀꯔꯗ ꯑꯗꯨꯈꯛ ꯇꯥꯛꯀꯦꯀꯣ ꯁꯤꯁꯦ ꯀꯩ ꯀꯧꯏ ꯗꯨ ꯌꯨ ꯅꯣ ꯗꯤꯁ ꯁꯤ ꯍꯥꯟꯅꯗꯤ ꯀꯩ ꯍꯥꯟꯅꯗꯤ ꯈꯪꯕ꯭ꯔꯁꯦ ꯁꯤꯒꯤ ꯄꯣꯖꯤꯁꯟꯁꯤ ꯀꯩ ꯀꯧꯔꯅꯤ This is Paul ama ꯀꯧꯕ꯭ꯔꯥ ꯀꯧꯗꯕ꯭ꯔꯣ
ꯑꯥ ꯑꯥ
ꯈꯪꯉꯤꯀꯣ ꯑꯗꯣ ꯅꯦꯛꯁꯇ ꯁꯤ ꯀꯩ ꯂꯥꯛꯀꯅꯤ ꯗꯤꯁ ꯏꯁ ꯐꯣꯀꯁꯅꯤꯅ ꯂꯥꯛꯄ꯭ꯔꯥ ꯗꯤꯁ ꯏꯁ ꯐꯣꯀꯁ ꯌꯥꯅꯤꯀꯣ ꯅꯦꯛꯁꯇ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔ ꯑꯃ ꯂꯥꯛꯄ꯭ꯔꯥ ꯂꯥꯛꯑꯦ ꯁꯤꯃ ꯀꯥꯎꯕ ꯌꯥꯗꯦꯀꯣ ꯑꯗꯨꯏꯗꯤ ꯁꯤꯒꯤ ꯂꯥꯏꯟꯁꯤꯅ ꯀꯩ ꯀꯧꯏ ꯗꯤꯁ ꯂꯥꯏꯟ ꯏꯁ ꯅꯣꯟ ꯑꯦꯁ ꯌꯣꯔ ꯄ꯭ꯔꯤꯟꯁꯤꯄꯥꯜ ꯑꯦꯛꯁꯤꯁ ꯗꯤꯁ ꯏꯁ ꯌꯣꯔ ꯄ꯭ꯔꯤꯟꯁꯤꯄꯥꯜ ꯑꯦꯛꯁꯤꯁ ꯌꯥꯒꯗ꯭ꯔꯥ ꯄ꯭ꯔꯤꯟꯁꯤꯄꯥꯜ ꯑꯦꯛꯁꯤꯁ ꯂꯩꯔꯦꯀꯣ ꯑꯗꯨꯒ ꯐꯣꯀꯁ ꯈꯪꯉꯦ ꯐꯣꯀꯁ ꯍꯥꯏꯁꯤ ꯀꯩꯅꯣ ꯐꯣꯀꯁ ꯍꯥꯏ ꯇꯥꯔꯗꯤ ꯅꯪꯅ ꯑꯦꯅꯤ ꯔꯤ ꯑꯃ ꯂꯧꯔꯦ ꯈꯜꯂꯁꯤꯀꯣ ꯑꯦꯅꯤ ꯔꯤ ꯑꯃ ꯂꯧꯕ ꯃꯇꯝꯗ ꯑꯥꯐꯇꯔ ꯔꯤꯐ꯭ꯂꯦꯛꯁꯟ ꯏꯠ ꯋꯤꯜ ꯑꯣꯜꯋꯦꯁ ꯇ꯭ꯔꯥꯏ ꯇꯨ ꯄꯥꯁ ꯊ꯭ꯔꯨ ꯗꯤꯁ ꯐꯣꯀꯁ ꯅꯪꯅ ꯑꯦꯅꯤ ꯔꯤ ꯑꯃ ꯂꯧꯕ ꯑꯦꯅꯤ ꯔꯤ ꯑꯃ ꯂꯧꯕ ꯃꯇꯝꯗ ꯃꯥꯁꯦ ꯀꯗꯥꯏꯗ ꯄꯥꯁ ꯇꯧꯒꯅꯦꯕ ꯏꯠ ꯋꯤꯜ ꯄꯥꯁ ꯊ꯭ꯔꯨ ꯗꯤꯁ ꯐꯣꯀꯁ ꯑꯥꯐꯇꯔ ꯔꯤꯐ꯭ꯂꯦꯛꯁꯟ ꯁꯤꯃ ꯑꯟꯗꯔꯁꯇꯦꯟ ꯇꯧꯕ ꯉꯝꯃꯕ ꯉꯝꯃꯦ ꯒ꯭ꯌꯥꯟ ꯇꯥꯅꯤꯀꯣ ꯑꯩ ꯍꯥꯏꯔꯤꯁꯦ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯑꯃꯨꯛ ꯁꯤ ꯂꯥꯛꯑꯣ ꯁꯤꯗ ꯐꯣꯀꯁ ꯂꯩꯔꯦ ꯁꯤꯗꯅ ꯀꯩ ꯂꯩꯔꯦ ꯗꯤꯁ ꯏꯁ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯥꯔꯚꯦꯆꯔ ꯑꯃ ꯂꯩꯔꯕ ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨꯗꯤ ꯁꯤ ꯑꯃꯇꯪꯒ ꯍꯥꯟꯅ ꯗꯥꯏꯒ꯭ꯔꯥꯝꯁꯦ ꯑꯩ ꯔꯤꯗ꯭ꯔꯣ ꯑꯃꯨꯛꯇꯪ ꯇꯧꯒꯦ ꯀꯟꯀꯦꯞ ꯃꯤꯔꯔꯅꯤꯀꯣ ꯌꯦꯛꯏꯁꯦ ꯑꯗꯨꯗꯤ ꯁꯤꯗ ꯗꯤꯁ ꯏꯁ ꯄꯣꯜ ꯑꯃ ꯂꯩꯔꯦ ꯗꯤꯁ ꯏꯁ ꯀꯅꯥ ꯑꯣꯏꯒꯗꯣꯏꯅꯣ ꯗꯤꯁ ꯏꯁ ꯐꯣꯀꯁꯅꯦꯅ ꯈꯜꯂꯣ ꯅꯦꯛꯁꯇ ꯀꯩ ꯂꯥꯛꯑꯅꯤ ꯗꯤꯁ ꯏꯁ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯥꯔꯚꯦꯆꯔ ꯍꯥꯏꯅ ꯍꯥꯏꯕ ꯌꯥꯕ꯭ꯔꯥ ꯌꯥꯔꯦꯀꯣ ꯑꯟꯗꯔꯁꯇꯦꯟ ꯇꯧꯕ ꯉꯝꯃꯦ ꯑꯗꯨꯏꯗꯤ ꯍꯤꯌꯔ ꯅꯪꯅ ꯈꯪꯒꯗꯧꯕꯁꯦ ꯑꯣꯞꯖꯦꯛ ꯄꯣꯖꯤꯁꯟ ꯑꯃ ꯌꯦꯡꯉꯁꯤ ꯑꯍꯥꯟꯕꯗ ꯌꯦꯡꯉꯣ ꯀꯔꯤꯒꯨꯝꯕ ꯏꯐ ꯗ ꯀꯔꯤ ꯑꯣꯏꯒꯗꯣꯏꯅꯣꯁꯦ ꯏꯐ ꯗ ꯏꯃꯦꯖ ꯑꯥꯔ ꯐꯣꯔꯝ ꯏꯟ ꯗꯤꯁ ꯁꯥꯏꯠ ꯁꯣꯝ ꯅꯥꯀꯟꯗ ꯐꯣꯔꯝ ꯇꯧꯕ ꯇꯥꯔꯗꯤ ꯃꯁꯤ ꯀꯩ ꯑꯣꯏꯒꯅꯤ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯑꯣꯏꯒꯗ꯭ꯔꯥ ꯑꯣꯏꯔꯣꯏꯗ꯭ꯔꯥ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖꯦꯁ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯕ ꯉꯝꯃꯤꯀꯣ ꯑꯗꯨꯒ ꯕꯤꯍꯥꯏꯟ ꯗ ꯃꯤꯔꯔ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯗꯤꯁ ꯏꯁ ꯚꯔꯆꯨꯋꯦꯜ ꯏꯃꯦꯖ ꯇꯥꯒꯗ꯭ꯔꯥ ꯇꯥꯔꯣꯏꯗ꯭ꯔꯥ ꯇꯥꯒꯅꯤ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯕ ꯉꯝꯃꯤ ꯉꯝꯃꯦꯀꯣ ꯑꯗꯨꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯑꯍꯥꯟꯕꯗ ꯂꯧꯗꯣꯏꯁꯦ ꯁꯨꯃꯥꯏꯅ ꯂꯧꯕꯤꯔꯣ ꯀꯣ ꯑꯣꯞꯖꯦꯛꯁꯦ ꯀꯗꯥꯏ ꯊꯝꯃꯦꯕ ꯏꯐ ꯗ ꯑꯣꯞꯖꯦꯛ ꯏꯁ ꯄ꯭ꯂꯦꯁ ꯑꯦꯠ ꯗ ꯚꯦꯔꯤ ꯐꯥꯔ ꯄ꯭ꯂꯦꯁ ꯁꯤꯒꯤ ꯅꯪ ꯏꯃꯦꯖ ꯂꯣꯀꯦꯁꯟꯁꯦ ꯍꯥꯟꯅꯗꯒꯤ ꯈꯪꯕ꯭ꯔꯥ ꯁꯤ ꯈꯪꯉꯒꯗꯤ ꯑꯩ ꯖꯔ ꯖꯔ ꯁꯝꯕ ꯌꯥꯗꯦꯕ
ꯑꯧ ꯈꯪꯉꯦ
ꯍꯥꯟꯅꯗꯩ ꯈꯪꯕ꯭ꯔꯕꯁꯦ
ꯑꯧ ꯈꯪꯉꯦ
ꯈꯪꯉꯦꯀꯣ
ꯎꯝ
ꯑꯗꯨꯗꯤ ꯑꯩ ꯁꯤ ꯖꯔ ꯍꯥꯏꯒꯦꯀꯣ ꯑꯣꯞꯖꯦꯛꯁꯤꯅ ꯏꯟꯐꯤꯅꯤꯇꯤ ꯊꯝ ꯇꯥꯔꯗꯤ ꯀꯗꯥꯏꯗ ꯐꯣꯔꯝ ꯇꯧꯒꯅꯤ ꯏꯃꯦꯖꯇꯣ ꯅꯪꯒꯤ ꯐꯣꯀꯁꯇ ꯐꯣꯔꯝ ꯇꯧꯒꯅꯤ ꯒ꯭ꯌꯥꯟ ꯇꯥꯏꯀꯣ ꯐꯣꯀꯁꯇ ꯃꯥꯁꯦ ꯀꯔꯝꯕ ꯑꯣꯏꯒꯅꯤꯁꯦ ꯏꯃꯦꯖ ꯑꯥꯏ ꯋꯥꯟ ꯑꯃ ꯍꯥꯏꯔꯒꯦ ꯏꯃꯦꯖ ꯑꯥꯏ ꯋꯥꯟ ꯈꯪꯉꯤꯀꯣ ꯁꯨꯃꯥꯏꯅ ꯏꯔꯣꯁꯦ ꯑꯣꯞꯖꯦꯛꯁꯦ ꯑꯦꯠ ꯏꯟꯐꯤꯅꯤꯇꯤ ꯁꯤꯅ ꯄꯣꯖꯤꯁꯟ ꯋꯥꯟꯅꯦꯅ ꯈꯜꯂꯁꯤ ꯄꯣꯖꯤꯁꯟ ꯅꯝꯕꯔ ꯐꯥꯔꯁ ꯄꯣꯖꯤꯁꯟꯁꯦ ꯑꯣꯞꯖꯦꯛꯁꯤꯅ ꯏꯟꯐꯤꯅꯤꯇꯤ ꯊꯝꯀꯥꯟꯗ ꯏꯃꯦꯖ ꯋꯤꯜ ꯕꯤ ꯐꯣꯔꯝ ꯑꯦꯠ ꯗ ꯀꯅꯥ ꯑꯣꯏꯒꯅꯤ ꯐꯣꯀꯁ ꯏꯠ ꯏꯁ ꯄꯣꯏꯟ ꯁꯥꯏꯖꯇ ꯑꯣꯏꯒꯅꯤ ꯔꯦꯜ ꯑꯣꯏꯒꯅꯤ ꯋꯥꯏ ꯏꯠ ꯏꯁ ꯔꯦꯜ ꯕꯤꯀꯣꯁ ꯔꯦꯜ ꯑꯣꯏꯗꯤ ꯕꯤꯀꯣꯁ ꯗꯤꯁ ꯏꯁ ꯐꯣꯔꯝ ꯏꯟ ꯐ꯭ꯔꯟ ꯑꯣꯐ ꯗ ꯃꯤꯔꯔꯒꯤ ꯏꯟ ꯐ꯭ꯔꯟꯇ ꯐꯣꯔꯝ ꯇꯧꯕꯅ ꯃꯔꯝ ꯑꯣꯏꯔꯒ ꯗꯤꯁ ꯏꯁ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯏꯀꯣ ꯔꯤꯌꯦꯜ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯌꯨ ꯁꯨꯠ ꯔꯤꯃꯦꯝꯕꯔ ꯗꯤꯁ ꯔꯤꯌꯦꯜ ꯑꯦꯟ ꯏꯟꯚꯔꯇꯦꯠ ꯁꯤ ꯔꯤꯌꯦꯜꯒ ꯏꯟꯚꯔꯇꯦꯠꯀꯁꯦ ꯅꯪ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯒꯗꯕꯅꯤ ꯍꯩꯒꯗꯕꯅꯤ ꯈꯪꯉꯅꯤ ꯅꯦꯛꯁꯇ ꯑꯃꯨꯛ ꯌꯦꯡꯉꯣ ꯋꯦꯟ ꯗ ꯑꯣꯕꯖꯦꯛ ꯏꯁ ꯄ꯭ꯂꯦꯁ ꯏꯟ ꯕꯤꯇ꯭ꯋꯤꯟ ꯀꯩ ꯑꯣꯏꯕ ꯏꯟ ꯕꯤꯇ꯭ꯋꯤꯟ ꯌꯣꯔ ꯏꯟꯐꯤꯅꯤꯇꯤ ꯑꯦꯟ ꯗ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔ ꯏꯟ ꯑꯅꯗꯔ ꯂꯦꯡꯒ꯭ꯋꯦꯖ ꯋꯦꯟ ꯗ ꯑꯣꯕꯖꯦꯛ ꯏꯁ ꯄ꯭ꯂꯦꯁ ꯕꯤꯌꯣꯟ ꯗ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔꯗ ꯊꯝꯃꯦ ꯈꯜꯂꯁꯤ ꯑꯣ ꯇꯨꯅꯦꯅ ꯈꯜꯂꯣ ꯀꯣ ꯑꯗꯨꯑꯣꯏꯗꯤ ꯏꯃꯦꯖ ꯋꯤꯜ ꯕꯤ ꯐꯣꯔꯝ ꯀꯗꯥꯏꯗ ꯐꯣꯔꯝ ꯇꯧꯅꯤ ꯕꯤꯇ꯭ꯋꯤꯟ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔ ꯑꯦꯟ ꯐꯣꯀꯁ ꯃꯥꯒꯤꯅ ꯑꯥꯏ ꯇꯨ ꯑꯃ ꯍꯥꯏꯔꯒꯦ ꯏꯃꯦꯖ ꯀꯩ ꯑꯣꯏ ꯏꯃꯦꯖ ꯋꯤꯜ ꯕꯤ ꯗꯤꯃꯤꯅꯤꯁ ꯏꯟ ꯁꯥꯏꯖ ꯃꯥꯒꯤ ꯁꯥꯏꯖꯇꯨ ꯗꯤꯃꯤꯅꯤꯁ ꯑꯣꯏ ꯏꯁꯃꯣꯂꯔ ꯑꯣꯏ ꯏꯟꯚꯔꯇꯦꯠ ꯑꯣꯏ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯔꯦꯀꯣ ꯅꯦꯛꯁꯇ ꯑꯃꯨꯛ ꯀꯃꯥꯏꯅ ꯈꯜꯂꯁꯤꯒꯦ ꯋꯦꯟ ꯗ ꯑꯣꯕꯖꯦꯛ ꯏꯁ ꯄ꯭ꯂꯦꯁ ꯑꯦꯠ ꯗ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔ ꯏꯃꯦꯖ ꯋꯤꯜ ꯕꯤ ꯐꯣꯔꯝ at the center of curvature itself but it must be opposite ꯑꯣꯏꯔꯅꯤ ꯁꯤꯅ ꯀꯩ ꯂꯥꯛꯑꯅꯤ I3 what is the basic criteria for this object position at center of curvature center of curvature ꯗ object ꯊꯝ ꯇꯥꯔꯗꯤ same position ꯗ inverted ꯑꯣꯏꯅ form ꯇꯧꯒꯅꯤ and what about the size will be equal size ꯀꯩꯗꯧꯔꯅꯤ ꯑꯅꯤꯁꯤ equal ꯑꯣꯏꯔꯅꯤ understand ꯇꯧꯔꯦꯀꯣ next ꯑꯍꯨꯝ ꯁꯨꯕꯗ ꯀꯃꯥꯏꯅ ꯊꯝꯃꯒꯦ let us put like this when the object is placed when the object is placed between center of curvature and the focus then image will be formed beyond center of curvature and it will be magnified ꯑꯣꯏꯔꯦꯀꯣ ꯁꯤꯅ ꯀꯩ ꯂꯥꯛꯅꯤ this is I4 so far ꯐꯪꯉꯤꯕ object ꯃꯌꯥꯝꯁꯦ ꯀꯩ ꯑꯣꯏꯔꯦ so far ꯐꯪꯉꯤꯕ object ꯐꯪꯉꯤꯕ image ꯃꯌꯥꯝꯁꯦ they are all real images and they are size increases. Understood tawre ko? Next the 5 tamu ko mai lorasige. If the object is placed at the focus tamtardi, the image will be highly magnified and it will be formed at infinity. Understood tawra? It will be formed at infinity. Gyan tawre. ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯀꯔꯤ ꯈꯪꯕ ꯉꯝꯃꯤ from position number 1 to position number 5 we have real images ꯈꯪꯉꯤꯀꯣ real images ꯑꯣꯏꯔꯦ and what about the size ꯃꯥꯒꯤ size increase ꯇꯧꯈꯤꯕ꯭ꯔꯥ ꯇꯧꯗꯕ꯭ꯔꯣ the size of the images increases once this object moves towards the mirror ꯑꯗꯨꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯗꯒꯤ ꯂꯧꯕ ꯌꯥꯔꯤꯕ interpretation ꯁꯦ ꯀꯩꯅꯣ the interpretation is that whenever the object is moving okay whenever the object is moving towards the mirror towards a concave mirror am laktaradi kaitore the image is moving away from the mirror and its size increases magi size to increase tobra tawi masi karambagino this will be the characteristic for real image ki ogina yaraba yareko adudi from infinity to focus it will produce real image understand tawreko now let us consider the last position that is within the focal length within focal length the image will be formed behind the mirror ki behind the form tawgani and it will be magnified maze kay ogani magnified so orani and kanazo ogani basa and it will be virtual understood tawba ngamra ngamdabra ngamme ai sida loshilladobani ko adu concave mirror se kay batare for this concave mirror all the images will be Kayugani real images whenever the object is placed from infinity to focus and if the object is placed within the focal length that is in between pole and the focus the image form will be behind the mirror and it will be magnified oigani and virtual oigani understood toroba yare sim khange ko concave mirror gi magi image formation lore next amu yongo convex ki mu yengaji ꯃꯤꯃꯤ ꯇꯥꯕ꯭ꯔꯥ ꯑꯩ ꯍꯥꯏꯁꯦ
ꯇꯥꯏ ꯁꯔ
ꯎꯝ ꯁꯤꯗ ꯑꯝꯇ ꯖꯁ ꯍꯟꯗꯛꯇꯤ ꯖꯁ ꯁꯝꯖꯜꯂꯗꯕꯅꯤꯀꯣ ꯍꯟꯗꯛꯅ ꯀꯔꯤ ꯑꯣꯏꯕ ꯇꯥꯔꯦ ꯗꯤꯁ ꯏꯁ ꯀꯟꯚꯦꯛꯁ ꯃꯤꯔꯔ ꯀꯟꯚꯦꯛꯁ ꯃꯤꯔꯔꯒꯤꯗꯗꯤ ꯅꯪꯅ ꯈꯪꯒꯗꯣꯏꯁꯦ ꯏꯠ ꯋꯤꯜ ꯐꯣꯔꯝ ꯑꯂꯣꯏꯁ ꯀꯅꯥ ꯑꯣꯏꯒꯗꯣꯏꯅꯣꯁꯦ ꯅꯪꯒꯤ ꯚꯔꯆꯨꯋꯦꯜ ꯏꯃꯦꯖ ꯐꯣꯔꯝ ꯇꯧꯒꯅꯦꯕ ꯚꯔꯆꯨꯋꯦꯜ ꯏꯃꯦꯖ ꯌꯥꯕ꯭ꯔꯥ ꯌꯥꯏꯀꯣ ꯑꯗꯨꯑꯣꯏꯗꯤ ꯅꯪꯅ ꯑꯣꯕꯖꯦꯛꯁꯦ ꯊꯝꯅꯤꯡꯕ ꯃꯐꯝ ꯊꯝꯃꯨ whenever the object is placed at infinity ꯇꯧꯕꯇꯕꯨ ꯀꯩꯗꯧꯕ ꯇꯥꯔꯦ object must be placed in front of the ꯀꯅꯥ ꯑꯣꯏꯕ ꯇꯥꯔꯦ in front of the mirror thamba tare let us put this is focus ne kalo this is our center of curvature ne khalaji adudi nang na saida si thame khalaji ko here and this is object I1 and O1 and khalaji this is object O2 ne khalaji it doesn't matter it will form image andakna this is I1 size na kayo gani say this is image I2 that means kari hagani all the image form will be in between pole and the focus pole ga focus ka oigani aduga magi kanu si kai oigdino sa diminish in size oigani what is the nature of the image formed by convex mirror is always virtual or reco always virtual or any diminish means it will be smaller in size or a yagadra yarani and it will be formed in between pole and the pole ga focus ka marakta laigani whatever the position of the object to be side thamgera it doesn't matter it will always produce image between pole and focus is that understood or not adu sikari yogani virtual gd it comes along with the erect haidi kaino straight oidiba upward oidiba gyan tabra khangani ko virtual ka erect ka real ka inverted ka sima khange convex mirror gi khangani ko adu magi uses khaga hairamsira convex mirror je kai organi se nang hayang pakada kai gum hanga ju khangnaba vehicle gi side mirror da kari usinai convex mirror aduga nangi concave mirror je kari da sinai dentist mirror on sinai bu yawi natraga kari ba saving mirror yabra saving mirror yai ko understood tawre ꯁꯤ ꯈꯪꯒꯗ꯭ꯔꯥ ꯈꯪꯉꯤꯀꯣ ꯅꯦꯛꯁꯇ
ꯑꯥ
ꯚꯦꯔꯤ
ꯈꯪꯉꯦ
ꯏꯝꯄꯣꯔꯇꯦꯟ ꯅꯪꯒꯤ ꯃꯤꯔꯔ ꯐꯣꯔꯃꯨꯂꯥ ꯍꯥꯟꯅꯗꯒꯤ ꯑꯟꯗꯔꯁꯇꯦꯟ ꯇꯧꯕ ꯉꯝꯃꯦꯀꯣ ꯍꯩꯔꯗ꯭ꯔꯥ ꯃꯤꯔꯔ ꯐꯣꯔꯃꯨꯂꯥꯗꯤ ꯀꯩ ꯃꯥꯟꯅꯩ 1/f=1/u+1 1/v f ꯁꯤꯅ ꯀꯩ ꯀꯧꯏ ꯐꯣꯀꯦꯜ ꯂꯦꯡ u ꯁꯤꯅ ꯀꯩ ꯀꯧꯅꯤ ꯑꯣꯕꯖꯦꯛ ꯗꯤꯁꯇꯦꯟꯁ b ꯅ ꯀꯩ ꯀꯧꯅꯤ ꯏꯃꯦꯖ ꯗꯤꯁꯇꯦꯟꯁ ꯑꯩ ꯗꯥꯏꯒ꯭ꯔꯥꯝ ꯑꯝꯇꯪ ꯌꯦꯛꯑꯒ ꯍꯥꯟꯅ ꯍꯥꯏꯍꯧꯒꯦꯁꯦ ꯁꯨꯃꯥꯏꯅ ꯊꯝꯃꯦ ꯈꯜꯂꯁꯦꯕ ꯁꯤ ꯂꯩꯕꯁꯦ ꯗꯤꯁ ꯏꯁ ꯐꯣꯀꯁ ꯑꯃ ꯂꯩꯕ꯭ꯔꯥ ꯗꯤꯁ ꯏꯁ ꯐꯣꯀꯁ ꯁꯤꯅ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔ ꯑꯃ ꯂꯩꯔꯦ ꯈꯜꯂꯁꯤ ꯑꯣꯕꯖꯦꯛꯁꯦ ꯀꯗꯥꯏ ꯊꯝꯃꯦ ꯑꯣꯕꯖꯦꯛꯁꯦ ꯑꯣꯕꯖꯦꯛ ꯏꯁ ꯄ꯭ꯂꯦꯁ ꯕꯤꯌꯣꯟ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔ ꯊꯝ ꯇꯥꯔꯗꯤ ꯁꯤꯗꯩꯅ ꯁꯤꯕꯨꯛꯀꯤ ꯑꯔꯥꯞꯄꯁꯦ ꯋꯤ ꯀꯦꯟ ꯄꯨꯠ ꯏꯠ ꯑꯦꯁ ꯌꯨ ꯑꯣꯏꯅ ꯂꯧꯒꯅꯦꯕ ꯌꯥꯒꯗ꯭ꯔꯥ ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨꯒ ꯏꯃꯦꯖꯇꯤ ꯀꯗꯥꯏꯗ ꯐꯣꯔꯝ ꯇꯧꯒꯅꯤ ꯑꯝꯇ ꯍꯥꯏꯔꯣ ꯏꯃꯦꯖ ꯋꯤꯜ ꯕꯤ ꯐꯣꯔꯝ ꯏꯟ ꯕꯤꯇ꯭ꯋꯤꯟ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔ ꯑꯦꯟ ꯐꯣꯀꯁ ꯁꯨꯃꯥꯏꯅ ꯐꯣꯔꯝ ꯇꯧꯒꯗ꯭ꯔꯥ ꯇꯧꯔꯣꯏꯗ꯭ꯔꯥ ꯁꯤꯅ ꯑꯣꯕꯖꯦꯛ ꯅꯠꯇ꯭ꯔꯣ ꯁꯤꯅ ꯏꯃꯦꯖ ꯑꯣꯏꯗꯣꯏ ꯅꯠꯇ꯭ꯔꯥ ꯗꯤꯁ ꯏꯁ ꯏꯃꯦꯖ ꯈꯪꯉꯤꯀꯣ ꯑꯩ ꯍꯥꯏꯔꯤꯁꯦ ꯁꯤꯗꯩꯁꯤꯕꯨꯛꯀꯤ
ꯑꯥ
ꯗꯤꯁꯇꯦꯟꯁꯅ ꯀꯌꯥ ꯑꯣꯏꯒꯅꯤ ꯗꯤꯁ ꯏꯁ ꯚꯤ ꯑꯃ ꯑꯣꯏꯕ꯭ꯔꯥ ꯑꯣꯏꯔꯦ ꯌꯥꯔꯅꯤ ꯁꯤꯗꯩꯅ ꯁꯤꯕꯨꯛꯁꯤꯅ ꯀꯩ ꯀꯧꯅꯤ ꯗꯤꯁ ꯏꯁ ꯐꯣꯀꯦꯜ ꯂꯦꯡ f
ꯐꯣꯀꯜ
ꯁꯣ ꯗ ꯔꯤꯂꯦꯁꯟ ꯕꯤꯇ꯭ꯋꯤꯟ ꯑꯣꯕꯖꯦꯛ ꯗꯤꯁꯇꯦꯟꯁ ꯀꯅꯥ ꯑꯣꯏꯒꯗꯣꯏꯅꯣꯁꯦ ꯑꯣꯕꯖꯦꯛ ꯗꯤꯁꯇꯦꯟꯁ ꯏꯃꯦꯖ ꯗꯤꯁꯇꯦꯟꯁ ꯑꯦꯟ ꯐꯣꯀꯦꯜ ꯂꯦꯡ ꯒꯤ ꯃꯣꯏꯒꯤ ꯔꯤꯂꯦꯁꯟꯁꯦ 1/f=1/u+1/v ꯗꯤꯁ ꯏꯁ ꯅꯣꯟ ꯑꯦꯁ ꯌꯣꯔ ꯃꯤꯔꯔ ꯐꯣꯔꯃꯨꯂꯥ ꯑꯃ ꯍꯥꯏꯔꯅꯤ ꯗꯨ ꯌꯨ ꯅꯣ ꯗ ꯁꯥꯏꯟ ꯀꯟꯚꯦꯟꯁꯟ ꯅꯪ ꯁꯥꯏꯟ ꯀꯟꯚꯦꯟꯁꯟꯗꯤ ꯍꯩꯕ꯭ꯔꯥ ꯍꯥꯟꯅꯗꯒꯤ
ꯍꯩ
ꯍꯩꯇꯦ ꯈꯪꯗꯦꯕꯀꯣ
ꯍꯩ
ꯁꯥꯏꯟ ꯀꯟꯚꯦꯟꯁꯟ ꯑꯩꯈꯣꯏꯒꯤ ꯍꯥ
ꯍꯩꯌꯦ ꯁꯨꯝ ꯑꯗꯨꯗꯤ
ꯍꯩꯌꯦ ꯑꯗꯨꯗꯤ ꯌꯨꯁꯤ ꯀꯩ ꯂꯧꯒꯅꯤ ꯋꯤꯜ ꯏꯠ ꯌꯨ ꯕꯤ ꯄꯣꯖꯤꯇꯤꯚ ꯑꯣꯔ ꯅꯦꯒꯦꯇꯤꯚ
ꯅꯦꯒꯦꯇꯤꯚ
ꯌꯨꯁꯦ ꯀꯩ ꯑꯣꯏꯒꯅꯤ ꯅꯦꯒꯦꯇꯤꯚ ꯚꯤꯁꯤꯅ ꯀꯩ ꯑꯣꯏꯒꯅꯤ ꯄꯣꯖꯤꯇꯤꯚ ꯑꯣꯏꯒꯗ꯭ꯔꯥ ꯑꯣꯏꯔꯅꯤ ꯑꯦꯐ ꯁꯤꯗꯤ ꯀꯩ ꯑꯣꯏꯒꯅꯤ
ꯁ꯭ꯃꯣꯜ
ꯑꯩꯅ
ꯑꯦꯐ
ꯍꯥꯏꯁꯤ ꯂꯥꯜꯂꯦ
ꯀꯦꯄꯤꯇꯦꯜ ꯑꯦꯐ
ꯚꯤꯁꯨ ꯀꯩ ꯑꯣꯏꯒꯅꯤ ꯚꯤ ꯋꯤꯜ ꯕꯤ ꯑꯣꯜꯁꯣ ꯅꯦꯒꯦꯇꯤꯚ ꯑꯦꯐ ꯋꯤꯜ ꯕꯤ ꯑꯣꯜꯁꯣ ꯅꯦꯒꯦꯇꯤꯚ ꯀꯩꯒꯤꯅꯣꯁꯦ ꯋꯥꯏ ꯕꯤꯀꯣꯁ ꯅꯪꯅ ꯂꯧꯔꯤꯁꯤ ꯀꯩꯅꯣ ꯑꯣꯕꯖꯦꯛꯇꯨꯗꯒꯤ ꯔꯦꯁꯦ ꯁꯨꯃꯥꯏꯅ ꯆꯠꯇꯣꯏ ꯅꯠꯇ꯭ꯔꯥ ꯔꯦ ꯏꯁ ꯒꯣꯌꯤꯡ ꯏꯟ ꯋꯤꯁ ꯗꯥꯏꯔꯦꯛꯁꯟ ꯏꯠ ꯏꯁ ꯒꯣꯌꯤꯡ ꯏꯟ ꯗ ꯔꯥꯏꯠ ꯍꯦꯟ ꯗꯥꯏꯔꯦꯛꯁꯟ ꯑꯦꯟ ꯋꯥꯠ ꯑꯕꯥꯎꯠ our measurement will always start from poleꯗꯒꯤ start ꯇꯧꯗꯧꯕꯅꯤ and our measurement is against the direction of the incident ray ꯑꯁꯤꯒꯤ directionꯒꯤ opposite ꯂꯥꯛꯄ꯭ꯔꯥ incident ray ꯒꯤ opposite ꯍꯦꯛ ꯆꯠ ꯇꯥꯔꯗꯤ we are going to take it as negative ꯑꯗꯨꯗꯤ ꯀꯩꯅ ꯍꯥꯏꯕ ꯇꯥꯔꯦ for ꯀꯩꯅꯣꯒꯤ ꯑꯣꯏꯕ ꯇꯥꯔꯗꯤ for concave ꯃꯤꯔꯔ ꯑꯃꯒꯤꯗꯤ all the parameters are negative ꯇꯥꯔꯅꯤ ꯍꯩꯔꯗ꯭ꯔꯥ ꯍꯩꯔꯦ ꯁꯤꯃ ꯈꯪꯉꯅꯤꯀꯣ ꯅꯦꯛꯁꯇ ꯅꯪꯒꯤ ꯀꯩꯅꯣꯒꯤꯗꯤ ꯀꯩ ꯂꯧꯒꯅꯤꯁꯦ ꯀꯟꯚꯦꯛꯁꯀꯤꯗꯤ ꯀꯃꯥꯏꯅ ꯂꯧꯕ ꯇꯥꯔꯦ ꯁꯨꯃꯥꯏꯅ ꯂꯧꯔꯒꯦꯀꯣ ꯑꯩꯅ ꯌꯦꯛꯏꯁꯦ ꯁꯣꯝꯗ ꯑꯣꯏꯅ ꯌꯦꯛꯄꯅ ꯐꯔꯅꯤ ꯁꯤꯅ ꯐꯔꯦ ꯁꯤꯅ ꯏꯖꯤ ꯑꯣꯏꯔꯅꯤ ꯀꯟꯚꯦꯛꯁꯀꯤ ꯑꯣꯏꯔꯦꯀꯣ ꯀꯟꯚꯦꯛꯁꯀꯤ ꯑꯣꯏꯅ ꯂꯧ ꯇꯥꯔꯗꯤ ꯑꯣꯕꯖꯦꯛ ꯑꯃ ꯊꯝꯃꯦ ꯗꯤꯁ ꯏꯁ ꯑꯣꯕꯖꯦꯛ ꯗꯤꯁ ꯏꯁ ꯄꯣꯜ ꯐꯣꯀꯁ ꯑꯃ ꯂꯩꯕ꯭ꯔꯥ ꯂꯩꯇꯕ꯭ꯔꯣ ꯑꯗꯨꯑꯣꯏꯗꯤ ꯍꯤꯌꯔ ꯗ ꯏꯟꯁꯤꯗꯦꯟ ꯔꯦ ꯋꯤꯜ ꯕꯤ ꯏꯟ ꯗ ꯏꯟꯁꯤꯗꯦꯟ ꯑꯣꯏꯗꯣꯏ ꯅꯠꯇ꯭ꯔꯣ ꯏꯟꯁꯤꯗꯦꯟ ꯗꯤꯁ ꯏꯁ ꯑꯣꯕꯖꯦꯛ ꯗꯤꯁꯇꯦꯟꯁꯅꯤ ꯗꯤꯁ ꯋꯤꯜ ꯕꯤ ꯇꯦꯀꯟ ꯑꯦꯁ ꯑꯂꯣꯏꯁ ꯅꯦꯒꯦꯇꯤꯚ ꯑꯣꯕꯖꯦꯛ ꯗꯤꯁꯇꯦꯟꯁ ꯁꯨꯗ ꯕꯤ lowest negative because object will be kept in front of the mirror ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨꯒ what about the focal length will be now taken as positive f will be taken as positive and what about the image distance this is image I this will be also positive ꯇꯥꯔꯗ꯭ꯔꯥ ꯇꯥꯔꯅꯤ ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨꯗꯤ ꯑꯗꯨꯗꯤ ꯅꯦꯛꯁꯇ ꯂꯩꯔꯤꯁꯦ ꯀꯩ ꯂꯩꯔꯦ ꯅꯪꯒꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯍꯥꯟꯅꯗꯒꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯈꯪꯕ꯭ꯔꯥ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯃꯔꯨ ꯑꯣꯏꯔꯤꯁꯦ ꯑꯩꯈꯣꯏꯒꯤ ꯁꯤꯒꯤ ꯆꯦꯞꯇꯔꯁꯤꯒꯤ ꯑꯣꯏꯅꯗꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯁꯦ ꯑꯁꯤ ꯍꯥꯟꯅ ꯈꯪꯕ ꯃꯊꯧ ꯇꯥꯏ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯈꯪꯗ ꯇꯥꯔꯒꯗꯤꯅꯦ ꯑꯦꯅꯤ ꯄ꯭ꯔꯣꯕ꯭ꯂꯦꯝ ꯑꯝꯇ ꯍꯣꯠꯄ ꯌꯥꯔꯣꯏ ꯑꯗꯨꯒ ꯄ꯭ꯔꯣꯕ꯭ꯂꯦꯝ ꯈꯨꯗꯤꯡꯃꯛꯁꯦ it will be solved with the help of our magnification ꯒꯤ ꯐꯣꯔꯃꯨꯂꯥꯁꯦ ꯍꯦꯛ ꯈꯪꯕ ꯇꯥꯔꯕ this will be the shortcut ꯑꯣꯏꯗꯣꯏꯕ ꯃꯥꯅ ꯌꯦꯡꯉꯣ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯍꯥꯏ ꯇꯥꯔꯗꯤ ꯀꯃꯥꯏꯅ ꯍꯥꯏꯒꯅꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ m is equal to ꯃꯥꯒꯤ ꯁꯤꯗ ꯂꯩꯔꯤꯁꯦ this is hi ꯍꯥꯏꯗꯤ ꯅꯠꯇ꯭ꯔꯥ divided by ho ꯍꯥꯏꯕꯗꯤ size of the image divided by size of the object ꯑꯩꯈꯣꯏꯅ magnification ꯍꯥꯏꯒꯅꯤ ꯑꯗꯨꯒ ꯅꯪꯅ ꯈꯪꯒꯗꯧꯕꯁꯦ you should be very careful ꯃꯔꯝꯗꯤ next topic ꯑꯩꯈꯣꯏꯅ ꯀꯔꯝꯕ ꯑꯃꯨꯛ ꯇꯝꯈꯤꯅꯤ ꯑꯩꯈꯣꯏꯅ ꯂꯦꯟꯁ ꯑꯃꯨꯛ ꯇꯝꯈꯤꯅꯦꯕ ꯂꯦꯟꯁ ꯇꯝꯕ ꯃꯇꯝꯗꯅꯦ ꯃꯥꯒꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯒꯤ ꯐꯣꯔꯃꯨꯂꯥꯁꯦ ꯃꯤꯔꯔꯒ ꯑꯜꯃꯣꯁꯠ ꯃꯥꯟꯅꯔ ꯆꯠꯀꯅꯤ ꯑꯗꯨꯗꯤ ꯁꯤꯗ ꯄ꯭ꯂꯁ ꯌꯥꯎꯒꯗ꯭ꯔꯥ ꯃꯥꯏꯅꯁ ꯌꯥꯎꯒꯗ꯭ꯔꯥ ꯃꯥꯏꯅꯁ ꯕꯤ ꯕꯥꯏ ꯌꯨ ꯑꯟꯗꯔꯁꯨ ꯇꯧꯏꯀꯣ ꯁꯤꯒꯤ ꯃꯥꯏꯅꯁꯁꯦ ꯗꯤꯁ ꯏꯁ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯒꯤ ꯐꯣꯔꯃꯨꯂꯥꯗ ꯌꯥꯎꯖꯔꯛꯄꯅꯤ ꯌꯥꯒꯗ꯭ꯔꯥ ꯏꯟ ꯇꯥꯔꯝꯁ ꯑꯣꯐ ꯗꯤꯁꯇꯦꯟꯁꯇ ꯍꯥꯏꯇꯥꯔꯒꯗꯤ ꯃꯥꯏꯅꯁ ꯑꯣꯐ ꯏꯃꯦꯖ ꯗꯤꯁꯇꯦꯟꯁ ꯗꯤꯚꯥꯏꯗꯦꯠ ꯕꯥꯏ ꯑꯣꯞꯖꯦꯛ ꯗꯤꯁꯇꯦꯟꯁ ꯌꯥꯔꯅꯤ ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨꯒ ꯀꯔꯤ ꯂꯥꯛꯑꯅꯤ ꯅꯦꯛꯁ ꯗꯤꯁ ꯋꯤꯜ ꯕꯤ ꯏꯀ꯭ꯋꯦꯜ ꯇꯨ ꯑꯩꯈꯣꯏꯅ ꯐꯣꯔꯃꯨꯂꯥꯗ ꯂꯩꯕꯗꯣ ꯑꯦꯐ ꯗꯤꯚꯥꯏꯗꯦꯠ ꯕꯥꯏ ꯀꯅꯥ ꯂꯥꯛꯀꯗꯣꯏꯅꯣꯁꯦ ꯑꯦꯐ ꯃꯥꯏꯅꯁ ꯌꯨ ꯑꯗꯨꯒ ꯏꯟ ꯇꯥꯔꯝꯁ ꯑꯣꯐ ꯀꯩꯅꯣꯗ ꯑꯦꯐ ꯃꯥꯏꯅꯁ ꯕꯤ ꯗꯤꯚꯥꯏꯗꯦꯠ ꯕꯥꯏ ꯑꯦꯐ ꯑꯩ ꯍꯥꯏꯁꯦ ꯈꯪꯍꯧꯕ꯭ꯔ ꯌꯦꯡꯉꯣ ꯀꯔꯤꯒꯨꯝꯕꯅꯦ ꯃꯥꯅ ꯄꯤꯔꯝꯃꯤꯕ ꯄꯦꯔꯥꯃꯤꯇꯔꯗꯣ ꯁꯥꯏꯖꯇ ꯄꯤꯔꯝ ꯇꯥꯔꯗꯤ ꯏꯐ ꯗ ꯁꯥꯏꯖ ꯑꯣꯐ ꯗ ꯏꯃꯦꯖ ꯑꯦꯟ ꯗ ꯑꯣꯕꯖꯦꯛ ꯏꯁ ꯒꯤꯚꯟ then you can easily find out the magnification by using this formula fast expression use tꯧꯕ ꯌꯥꯔꯦ ꯑꯗꯨꯒ if object distance and image distance are given then you are going to use the second and if instead of giving the image distance they simply give you focal length and object distance magnification can also be calculated by using this third expression okay mathangda kai lai final expression na kamai mai batare if focal length along with the object image distance is given then magnification can be calculated by using this last expression and this magnification जब खोने की कवनी से this is linear magnification कवनी को अदु linear magnification करम मतमदा apply तौदगे for a better understanding सुमाइना आई हते इरगे when the object से करी थमे when the object is placed upright है perpendicular नत्रा perpendicular to the principal axis and the image is also formed perpendicular upside to be upside to oragana kay ugani se this is virtual odinatro this is virtual sine kay ugani this is real bro oida bro sine object amo oibra oire adudi if all the objects and if all the objects and images okay if all the object and the images are perpendicular to the kana within principal axis then the magnification produced in that condition will be known as linear magnification कौगने अंडरस्टूड तौरबा तौद्रिबा याइको खंगी को यारिजे हा यारद्रा मिमी याइको से
यारे सर
अदुगा नेक्स्ट अमु येंगो मागी magnification gi magi characteristic amu yengu masi if the magnification is negative then what will be the nature of the image kya hoigani kari hoigani what will be the nature of the image हांदे खंगब्रा खंगदब्रो हांदगी सिदगी if the calculation of our linear magnification comes to be negative tare khalajeba adi magi nature of image se asima hana khangmo mathau tai nangi negative way hoita it will be real hoigane real hoita krai form tawani it will be in front of the mirror khangani ko real dadi kam hoibe real dadi it may be koina image form by real image kana kana form tawngami real image kana form tawngam ge mirror da koina tamise there are three types of mirror na tro mirror sida number 1 sida plane mirror am lere number 2 da concave mirror am lebra number 3 da kai lere number 3 da your convex mirror am tabra tare adu di plane mirror ga convex mirror ga di will always form these two will always form kana form tawi virtual images and what about concave mirror will form real image man of produce to the real image ka udinatra that if the magnification comes out to be real oita radi kayugani what will be the type of nangi mirror use the mirror use will be concave oigani simazu understand to wa higidoba concave oirani ko मतलब concave se kona isi nangi real oirani real dadi magi size to kaidawo yai koina point size oibe yai diminish oibe yai point size oibe yai diminish hai smaller oibe yai gyan dai ko diminish oibe yai next kari oibesu yai ba maje equal oibesu yai aduga kai oiba magnified oibesu yai understood tawi tawde tawri ko aduga maje karamba image to form tawgani it will be formed by concave mirror sina khak form tawgani yai yade yare ko adudi angtang hairo se si haibreng si Next, magnification sina positive ne na khalo. Positive oitardi it will be virtual organi masi kana organi se it may be nangi equal oibe ai. It may be equal oibe ai. Size to equal oibe ai ko magnified oibe ai. Equal oibe ai magnified oibe ai. Aduga diminish ꯑꯣꯏꯔꯁꯨ ꯌꯥꯏ diminish ꯑꯣꯏꯔꯁꯨ ꯌꯥꯏ ꯑꯗꯨꯗꯤ ꯑꯝꯇꯪ ꯍꯥꯏꯔꯛꯑꯣ ꯑꯁꯤ ꯇꯧꯔꯒ ꯑꯪꯀ ꯍꯣꯠꯂꯁꯤꯀꯣ m is equal to plus 1 ꯁꯤ ꯀꯅꯥꯒꯤ magnification ꯑꯣꯏꯒꯅꯤ what is the type of mirror ꯀꯔꯝꯕ mirror ꯑꯣꯏꯗꯣꯏꯅꯣ ꯑꯩꯈꯣꯏꯅ mirrorꯁꯤ ꯃꯈꯜ ꯑꯍꯨꯝ ꯇꯝꯃꯤꯗꯅ plane mirror concave mirror ꯑꯗꯒꯤ convex mirror ꯑꯣꯏꯗꯅ if the magnification comes out to be plus 1 plus 1 ꯑꯣꯏꯇꯥꯔꯗꯤ what will be the type of mirror use mirror ꯀꯔꯝꯕ ꯑꯣꯏꯔꯅꯤ
Future. Future. Uh,
ꯍꯥ
convex.
convex
Oh.
ꯑꯗꯨꯗꯤ ꯌꯥꯗ꯭ꯔꯦ ꯁꯤꯗ ꯅꯪꯅ ꯑꯗꯨꯅꯦ ꯁꯦ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯃꯔꯨ ꯑꯣꯏꯔꯤꯁꯤ ꯀꯩꯒꯤꯅꯣ ꯍꯥꯏꯗꯤ ꯌꯨ ꯁꯨꯗ ꯍꯦꯚ ꯗ ꯚꯦꯔꯤ ꯀ꯭ꯂꯤꯌꯥꯔ ꯀꯟꯁꯦꯞꯁꯤ ꯃꯨꯟꯅ ꯈꯪꯕ ꯇꯥꯏꯕ ꯑꯗꯨꯗꯤ ꯀꯟꯚꯦꯛꯁꯀꯤꯗꯗꯤ ꯏꯟ ꯀꯦꯁ ꯑꯣꯐ ꯗ ꯀꯟꯚꯦꯛꯁ ꯃꯤꯔꯔꯒꯤꯗꯗꯤ ꯅꯪꯅ ꯑꯣಬ್ꯖꯦꯛꯁꯤ ꯀꯩ ꯑꯣꯏꯔꯦ ꯑꯣꯕꯖꯦꯛ ꯏꯁ 5 cm ꯈꯜꯂꯁꯦꯕ ꯑꯗꯨꯒ ꯋꯥꯠ ꯋꯤꯜ ꯕꯤ ꯗ ꯏꯃꯦꯖ ꯅꯪ ꯗꯤꯁ ꯏꯁ ꯐꯣꯀꯦꯜ ꯂꯦꯡ ꯐꯣꯀꯁ ꯑꯃ ꯂꯥꯛꯑꯅꯤ ꯏꯃꯦꯖ ꯋꯤꯜ ꯕꯤ ꯑꯂꯣꯏꯁ ꯗꯤꯃꯤꯅꯤꯁ ꯍꯥꯏꯕ꯭ꯔꯥ ꯍꯥꯏꯗꯕ꯭ꯔꯣ ꯑꯂꯣꯏꯁ ꯗꯤꯃꯤꯅꯤꯁ ꯃꯤꯟꯁ ꯏꯠ ꯋꯤꯜ ꯕꯤ 1 cm or 2 cm ꯑꯣꯏꯗꯣꯏꯅꯦꯕ ꯑꯗꯨꯗꯤ ꯑꯋꯥꯔ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯀꯦꯅꯣꯠ ꯕꯤ ꯒ꯭ꯔꯦꯇꯔ ꯗꯦꯟ 1ꯗꯒꯤ ꯍꯦꯟꯅ ꯇꯥꯕ ꯌꯥꯔꯣꯏꯕ 1ꯁꯤ ꯀꯔꯝꯕ ꯃꯇꯝꯗ ꯑꯣꯏꯒꯗꯣꯏꯅꯣ 1 ꯃꯤꯟꯁ the size of the image and the size of the object must be equal that means ꯀꯔꯤ ꯑꯣꯏꯕ ꯇꯥꯔꯦ if this is a plane mirror ꯑꯣꯏꯕ ꯇꯥꯔꯗꯤ if this is 5 cm ꯑꯣꯏꯔꯦ ꯈꯜꯂꯣ and image will be also 5 cm is that understood ꯌꯥꯗ꯭ꯔꯥ ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨꯗꯤ +1 ꯑꯣꯏꯇꯥꯔꯒꯗꯤ this will be our ꯀꯩ ꯑꯣꯏꯒꯅꯤ plane mirror ꯁꯤ ꯈꯪꯍꯧꯔꯕ ꯈꯪꯍꯧꯗ꯭ꯔꯤꯕ
Oh.
ꯒ꯭ꯌꯥꯟ ꯇꯥꯕ꯭ꯔꯥ
Uh.
ꯈꯪꯉꯦꯀꯣ
Oh.
ꯌꯥꯔꯅꯤ ꯑꯗꯨ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯁꯤꯅ 0.6 ꯑꯣꯏꯔꯦ ꯈꯜꯂꯁꯤ this will be concave ꯌꯥꯒꯗ꯭ꯔꯥ ꯍꯥꯏꯗꯤ ꯁ꯭ꯃꯣꯂꯔ ꯑꯣꯏꯕ꯭ꯔꯣ ꯑꯣꯏꯗꯕ꯭ꯔꯣ ꯍꯥꯏꯕꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯂꯧꯔꯤꯁꯤ ꯀꯩꯅꯣ ꯏꯃꯦꯖꯀꯤ ꯄꯦꯔꯥꯃꯤꯇꯔꯗꯨꯗ ꯀꯅꯥꯅ ꯌꯦꯟꯗꯣꯏꯅꯣ ꯑꯣꯕꯖꯦꯛꯅ ꯌꯦꯟꯗꯣꯏꯅꯦꯕ ꯑꯗꯨꯗꯤ ꯋꯦꯟ ꯑꯦꯚꯔ ꯗꯤꯁ ꯏꯁ 2 ꯗꯤꯚꯥꯏꯗꯦꯠ ꯕꯥꯏ ꯅꯪꯒꯤ 3ꯅ ꯂꯧꯔꯦ ꯈꯜꯂꯁꯤ ꯗꯤꯁ ꯏꯁ 0.6 ꯐꯪꯕ꯭ꯔꯥ ꯐꯪꯗꯕ꯭ꯔꯥ ꯑꯗꯨ ꯗꯦꯠ ꯃꯤꯟꯁ your object size is greater than image size or in another language we can say that the image form is diminish ꯇꯧꯋꯦꯅ ꯍꯥꯏꯒꯗꯣꯏꯅꯤꯀꯣ ꯑꯗꯨꯗꯤ when ever plus ꯃꯥꯒꯤ magnification ꯗꯣ plus 2 ꯍꯦꯛ ꯑꯣꯏꯇꯥꯔꯕ we can say thatꯀꯔꯤ ꯑꯣꯏꯒꯅꯤ it may be plane mirror or concave mirror and just by looking at the value ꯃꯥꯒꯤ value ꯗꯤ ꯌꯦꯡꯉꯣ 1 ꯑꯣꯏꯇꯥꯔꯒꯗꯅ plane mirror ꯑꯣꯏꯒꯅꯤ and less than 1 ꯑꯣꯏꯇꯥꯔꯒꯅ if the magnification is less than 1 then it will be concave mirror ꯌꯥꯔꯗ꯭ꯔꯥ concave ꯍꯥꯏꯕ ꯅꯠꯇꯦ convex ꯍꯥꯏꯒꯗꯕ sorry convex ꯍꯥꯏꯒꯗꯕꯅꯤꯀꯣ ꯑꯩꯅ ꯍꯥꯏꯕꯗ ꯁꯣꯏꯈ꯭ꯔꯦ ꯌꯥꯔꯗ꯭ꯔꯥ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯔꯦꯀꯣ ꯑꯗꯨꯒ ꯑꯃꯨꯛ ꯁꯤꯗ ꯑꯃꯨꯛ magnification m is equal to -1 ꯁꯤꯗꯤ ꯀꯔꯝꯕ ꯑꯣꯏꯔꯅꯤ ꯃꯥꯏꯅꯁ ꯍꯦꯛ ꯌꯥꯎ ꯇꯥꯔꯗꯤ ꯌꯨ ꯐꯣꯔꯒꯦꯠ ꯑꯕꯥꯎꯠ ꯀꯩꯅꯣꯁꯤ ꯂꯣꯏꯅ ꯀꯥꯎꯊꯣꯛꯈ꯭ꯔꯣ ꯑꯗꯨꯒ ꯀꯟꯀꯦꯞ ꯑꯃꯨꯛ ꯑꯣꯏꯒꯦꯔꯥ ꯑꯣꯏꯔꯣꯏꯗ꯭ꯔꯣ ꯃꯔꯝꯗꯤ ꯃꯥꯏꯅꯁ ꯋꯤꯜ ꯕꯤ ꯑꯣꯡꯂꯤ ꯐꯣꯔ ꯔꯦꯜ ꯋꯤꯜ ꯕꯤ ꯐꯣꯔꯝ ꯕꯥꯏ ꯀꯅꯥ ꯑꯣꯏꯗꯣꯏꯅꯣ ꯀꯟꯚꯦꯛꯁ ꯇꯥꯗꯣꯏ ꯅꯠꯇ꯭ꯔꯣ
Concave.
ꯀꯟꯀꯦꯞ ꯇꯥꯗꯣꯏ ꯅꯠꯇ꯭ꯔꯣ ꯌꯥꯔꯗ꯭ꯔꯥ ꯌꯥꯔꯦ ꯈꯪꯉꯦꯀꯣ
Oh.
ꯌꯥꯔꯗ꯭ꯔꯣ
ꯌꯥꯔꯅꯤ sir.
ꯑꯗꯨꯗꯤ ꯑꯪꯀ ꯍꯣꯜꯂꯁꯤꯔꯥ
Oh.
ꯑꯪꯀ
ꯍꯣꯠꯂꯁꯤ.
ꯍꯣꯜꯂꯁꯤ ꯇꯥꯛꯇꯨꯕꯕꯨꯗꯤ ꯀꯩꯅꯣ ꯋꯥꯠꯂꯤꯕꯀꯣ ꯑꯗꯨꯝ ꯂꯣꯏ ꯇꯥꯛꯂꯩꯗꯤ ꯌꯥꯔꯔꯣꯏ ꯁꯤꯅ ꯂꯣꯡꯒꯤꯇ꯭ꯌꯨꯗꯅꯦꯜ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯁꯨꯄꯔꯐꯤꯁꯤꯌꯦꯜ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯑꯩ ꯍꯣꯔꯦꯟ ꯑꯪꯀ ꯍꯣꯠꯄꯗ ꯑꯗꯨꯝ ꯇꯥꯛꯂꯛꯑꯒꯦꯀꯣ ꯍꯧꯖꯤꯛꯀꯤ ꯑꯣꯏꯅꯗꯤ let us go through what calculationꯁꯤꯗ ꯍꯣꯠꯂꯁꯤ question number 1 मान spherical mirror दे हन हौरेको reflection by spherical mirror an object is question जो उब्रा is it the question visible clearly या make sing
Oh.
उब्रा ꯌꯦꯡꯉꯣ an object is placed at a distance of 40 centimeter from a concave mirror of pocket length 15 centimeter. ꯑꯗꯨꯏꯗꯤ ꯅꯪꯅꯅꯦ before solving ꯅꯪꯅ diagram ꯅꯨꯡꯒ ꯑꯝꯇ ꯌꯦꯛꯇ꯭ꯔꯤꯀꯥꯟꯁꯤꯗꯅꯦ ꯍꯥꯏꯗꯤ ꯐꯣꯔꯃꯨꯂꯥ ꯄꯥꯟꯗ꯭ꯔꯤꯀꯥꯟꯁꯤꯗ you just draw the diagramꯁꯤ ꯍꯩꯕ꯭ꯔꯥ ꯌꯦꯡꯉꯣꯀꯣ ꯁꯨꯃꯥꯏꯅ ꯌꯦꯛꯑꯁꯤꯀꯣ ꯁꯤ ꯂꯩꯔꯦ concave ꯍꯥꯏꯔꯝꯕ ꯅꯠꯇ꯭ꯔꯥ concave mirror ꯍꯥꯏꯗꯤ concave mirror ꯑꯃ ꯌꯦꯛꯄꯤꯔꯦ focal length this is f ꯍꯥꯏꯕ ꯅꯠꯇ꯭ꯔꯥ this is focal length this is ꯅꯪꯒꯤ center of curvature C ꯑꯩꯅ ꯍꯥꯏꯍꯧꯗꯕ ꯑꯃ ꯂꯩꯔꯦ what is the relation between radius of curvature and focal length it will be 2 times ꯑꯃ ꯑꯣꯏꯗꯣꯏ ꯅꯠꯇ꯭ꯔꯥ ꯑꯗꯨ ꯃꯥꯅ ꯄꯤꯔꯤꯁꯦ ꯁꯤꯗꯩ ꯁꯤꯐꯥꯎ ꯀꯌꯥꯅꯣ if it is 15 ꯍꯥꯏꯅ ꯄꯤꯕ꯭ꯔꯥ ꯄꯤꯗꯕ꯭ꯔꯣ 15 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯑꯃ ꯄꯤꯔꯦꯀꯣ ꯑꯗꯨꯒ what is the object where is the object kept object ꯁꯤ ꯀꯗꯥꯏꯗ kept ꯇꯧꯏ object is placed at a distance 40 centimeter from the concave mirror ꯍꯥꯏꯕꯅꯦꯕ ꯑꯗꯨ 40 centimeter ꯍꯥꯏꯇꯥꯔꯗꯤ here ꯁꯤꯗꯩ ꯁꯤꯐꯥꯎꯁꯤ ꯀꯌꯥ ꯑꯣꯏꯗꯣꯏꯅꯣꯁꯦ center of curvature ꯁꯦ it will be 30 ꯑꯣꯏꯒꯗ꯭ꯔꯥ ꯑꯣꯏꯔꯣꯏꯗ꯭ꯔꯣ 30 centimeter that means we can say that the object is placed beyond center of curvature object ꯁꯤ ꯀꯗꯥꯏ ꯊꯝꯃꯤ beyond center of curvature ꯊꯝꯕ ꯅꯠꯇ꯭ꯔꯣ 40 centimeter u is equal to minus 40 centimeter ꯌꯥꯒꯗ꯭ꯔꯥ ꯌꯥꯔꯣꯏꯗ꯭ꯔꯥ ꯑꯗꯨꯗꯤ whenever ꯁꯤꯗ ꯅꯪꯅ ꯈꯪꯉꯣ whenever the object is placed beyond center of curvature image is going to be formed in between center of curvature and focus adudi answer je karai lakani our answer will be from 15 answer gi range karai lakani answer gi range se 15 dagina 30 bau ki range ta lakadu natra ai hai understood tau ngambra khangibro khangdabro ai ngangi je logical interpretation je khangi ko ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯒꯗꯤ ꯐꯥꯔꯁ ꯀꯦꯁꯇ ꯃꯥꯅ ꯂꯥꯛꯇꯣꯏꯁꯦ ꯀꯗꯥꯏꯗ ꯂꯥꯛꯑꯅꯤꯁꯦ the image will be formedꯀꯗꯥꯏꯗ ꯐꯣꯔꯝ ꯇꯧꯔꯅꯤ in between 15 ꯍꯥꯏꯗꯤ in between focus and center of curvature ꯁꯤ ꯂꯩꯔꯦ anyway ꯀꯣꯏꯁꯟꯁꯦ ꯃꯈꯥ ꯇꯥꯅ ꯄꯥꯁꯤ if the object is displaced through a distance 20 centimeter towards the mirror ꯑꯗꯨꯗꯤ ꯃꯥꯁꯦ ꯀꯗꯥꯏꯗ ꯊꯝꯃꯗꯣꯏꯅꯣ ꯍꯟꯗꯛꯅ ꯁꯤꯒꯤ ꯑꯣꯕꯖꯦꯛꯁꯤ ꯁꯤ ꯂꯩꯔꯝꯕ ꯅꯠꯇ꯭ꯔꯥ ꯑꯣꯕꯖꯦꯛꯀꯤ ꯑꯍꯥꯟꯕ ꯄꯣꯖꯤꯁꯟꯁꯦ let us put this as O1 ꯑꯃ ꯍꯥꯏꯔꯁꯤꯀꯣ ꯁꯤꯝꯊꯠꯀꯦꯀꯣ ꯁꯤꯗ this is O1 ꯑꯃ ꯍꯥꯏꯔꯒꯦ O1 ꯁꯤꯒꯤ ꯗꯤꯁꯇꯦꯟꯁꯁꯤ ꯀꯌꯥꯅꯣ U1 U1 ꯒꯤ ꯗꯤꯁꯇꯦꯟꯁꯁꯤ ꯀꯌꯥꯅꯣ this is 40 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯂꯩꯔꯦ ꯑꯗꯨꯒ ꯍꯟꯗꯛꯅ ꯁꯤ 30 ꯁꯤꯃ ꯑꯩ ꯃꯨꯊꯠꯀꯦꯀꯣ ꯁꯤꯅ ꯀꯩ ꯑꯣꯏꯅꯤ this is image position I1 ꯑꯃ ꯂꯥꯛꯄ꯭ꯔꯥ ꯂꯥꯛꯏꯀꯣ ꯑꯗꯨꯗꯤ ꯑꯃꯨꯛꯇꯪ ꯍꯥꯏꯔꯣꯁꯦ ꯃꯈꯥꯒꯤ ꯁꯦꯀꯦꯟ ꯁ꯭ꯇꯦꯠꯃꯦꯟꯁꯦ ꯑꯁꯤꯃꯇꯪ ꯄꯥꯔꯒ ꯀꯩꯅꯣꯁꯦ ꯑꯟꯁꯔꯁꯦ ꯗꯤꯗ꯭ꯌꯨꯁ ꯇꯧ ꯉꯝꯕ꯭ꯔꯥ ꯌꯦꯡꯁꯤ if the object is displaced ꯍꯥꯏꯗꯤ move ꯍꯥꯏꯕꯅꯤꯀꯣ through a distance of 20 centimeter towards the mirror 20 centimeter ꯆꯪꯁꯤꯜꯂꯦ ꯍꯥꯏꯔꯦ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ here ꯁꯤꯗꯩꯁꯤꯕꯨꯛꯇꯤ 30 ꯂꯩꯕ꯭ꯔꯥ 40 ꯂꯩ ꯑꯗꯨꯗꯤ ꯀꯗꯥꯏ ꯂꯩꯔꯅꯤ ꯁꯤꯗꯩꯁꯤꯕꯨꯛꯁꯦ ꯍꯥꯏꯕꯗꯤ from the pole to this initial position it is at 40 centimeter now it is displaced by 20 centimeter that means from here to here this will be 10 centimeter natro understand tawbo ngami ngamde ngamiko adi 20 centimeter displaced tawbo haiba 30 kai tare it will be somewhere here somewhere side like lakada laoidra object o2 understand tawbo ngami gyan tabra ꯈꯪꯉꯤꯀꯣ ꯑꯗꯩ ꯑꯣꯕꯖꯦꯛꯁꯤ ꯀꯔꯝ ꯂꯩ the object comes ꯀꯅꯥ ꯑꯣꯏꯒꯗꯣꯏꯅꯣ the object comes closer to the mirror closer ꯑꯣꯏꯇꯥꯔꯗꯤ image ꯀꯗꯥꯏ form ꯇꯧꯒꯅꯤ we know that when the object is placed between center of curvature and focus it will be the image will form beyond center of curvature sina I2 ꯑꯃ ꯂꯥꯛꯀꯗ꯭ꯔꯥ ꯂꯥꯛꯑꯣꯏꯗ꯭ꯔꯥ ꯂꯥꯛꯀꯅꯤ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ the answer will be ꯍꯟꯗꯛꯀꯤ I2 ꯒꯤ ꯍꯥꯏꯕꯗꯤ this will be greater than kya hoigani tangi v2 se kya hoiba tare v2 will be greater than 30 dagi hena chawadra charoidro chaurani understood tawbo ngami ngamde ngami ko harise habdi it will be from beyond center of curvature lere adi ma se move away oidi natra move away oidi tardi move towards the oriba option number C ga D ga je cancel chatpa yabra eliminate tawba yabra yare ko harise ꯑꯩꯅ ꯇꯥꯛꯏꯕ ꯂꯣꯖꯤꯛꯁꯦ ꯅꯪꯅ ꯑꯦꯛꯖꯥꯝꯗ ꯇꯥꯏꯝ ꯂꯤꯃꯤꯇꯦꯁꯟ ꯂꯩꯔꯦ ꯍꯥꯏꯕꯗꯤ ꯇꯥꯏꯝ ꯂꯩꯇ꯭ꯔꯦꯅ ꯈꯜꯂꯣ ꯅꯠꯇ꯭ꯔꯒ ꯅꯪꯅ ꯐꯣꯔꯃꯨꯂꯥ ꯀꯥꯎꯈ꯭ꯔꯦ ꯈꯜꯂꯁꯤ ꯗꯤꯁ ꯏꯁ ꯗ ꯏꯖꯤꯌꯦꯁ ꯋꯦ ꯌꯨ ꯖꯁ ꯏꯂꯤꯃꯤꯅꯦꯠ ꯇꯨ ꯑꯣꯞꯁꯟ ꯕꯥꯏ ꯌꯨꯖꯤꯡ ꯗ ꯀꯟꯁꯦꯞꯁꯤ ꯀꯔꯤ ꯍꯥꯏ ꯋꯦꯟ ꯑꯦꯚꯔ ꯗ ꯑꯣꯕꯖꯦꯛ ꯀꯝꯁ ꯀ꯭ꯂꯣꯖꯔ ꯇꯨ ꯗ ꯃꯤꯔꯔ ꯃꯤꯔꯔꯒꯤ ꯃꯅꯥꯛꯇ ꯆꯪꯁꯤꯜꯂꯛꯄ ꯇꯥꯔꯗꯤ ꯗ ꯏꯃꯦꯖ ꯃꯨꯚ ꯑꯦꯋꯦ ꯐ꯭ꯔꯣꯝ ꯗ ꯃꯤꯔꯔꯗꯒꯤ ꯂꯥꯞꯊꯣꯛꯑ ꯆꯠꯈꯤꯕ ꯅꯠꯇ꯭ꯔꯥ ꯑꯗꯨꯗꯤ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ ꯁꯤ ꯑꯦꯟ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ ꯗꯤ ꯏꯁ ꯏꯂꯤꯃꯤꯅꯦꯇꯦꯠ ꯑꯗꯨꯗꯤ ꯋꯥꯠ ꯋꯤꯜ ꯕꯤ ꯗ ꯑꯟꯁꯔ ꯋꯤꯜ ꯕꯤ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ ꯑꯦ ꯑꯣꯔ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ ꯕꯤ ꯇꯥꯔꯅꯦꯕ ꯌꯨ ꯀꯦꯟ ꯇꯦꯛ 50-50 ꯆꯥꯟꯁ 50-50 ꯆꯥꯟꯁ ꯅꯪꯅ ꯂꯧꯕ ꯌꯥꯔꯅꯦꯕ ꯌꯥꯒꯗ꯭ꯔꯥ ꯌꯥꯔꯣꯏꯗ꯭ꯔꯣ ꯑꯩ ꯍꯥꯏꯁꯦ ꯈꯪꯍꯧꯔꯕ ꯈꯪꯍꯧꯗ꯭ꯔꯤꯕ
ꯈꯪꯉꯦ
ꯒ꯭ꯌꯥꯟ ꯇꯥꯔꯕ
ꯇꯥꯔꯦ
ꯃꯤꯃꯤ ꯈꯪꯕ꯭ꯔꯥ ꯑꯩ ꯍꯥꯏꯖꯦ
ꯑꯥꯎ ꯈꯪꯉꯦ ꯁꯥꯔ
ꯎꯝ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯑꯪꯀꯁꯦ ꯀꯃꯥꯏꯅ ꯍꯣꯠꯀꯅꯤ ꯁꯤꯗ ꯅꯪꯅ ꯌꯥꯝ ꯀꯝꯄ꯭ꯂꯦꯛꯁ ꯑꯣꯏꯅ ꯑꯗꯨ ꯑꯗꯥ ꯍꯥꯏꯅ ꯂꯧꯕꯒꯤ ꯃꯍꯨꯠꯇꯅꯦ ꯑꯩꯈꯣꯏꯅ ꯐꯣꯝꯂꯥꯗꯒꯤ ꯑꯣꯏꯅ ꯍꯣꯠꯂꯁꯤ ꯁꯤꯒꯤ ꯄꯣꯖꯤꯁꯟ ꯅꯝꯕꯔ 1 ꯄꯣꯖꯤꯁꯟ ꯅꯝꯕꯔ 2ꯁꯦ ꯍꯦꯛꯇ ꯃꯨꯊꯠꯈꯤꯒꯦꯕꯀꯣ ꯄꯣꯖꯤꯁꯟ 2ꯒꯁꯦ ꯍꯦꯛꯇ ꯃꯨꯊꯠꯈꯤꯒꯦ ꯀꯟꯁꯦꯞꯇꯤ ꯈꯪꯉꯦꯀꯣ ꯑꯟꯁꯔꯗꯤ ꯁꯤ ꯇꯥꯔꯅꯤꯁꯦ ꯑꯗꯨ ꯃꯌꯥꯝꯅ ꯀꯟꯚꯦꯟꯁꯅꯦꯜ ꯑꯣꯏꯅ ꯃꯣꯁ ꯑꯣꯐ ꯗ ꯏꯁꯇꯨꯗꯦꯟꯅ ꯍꯣꯠꯇꯣꯏꯁꯦ ꯀꯔꯝꯕ ꯍꯣꯠꯀꯅꯤ ꯗꯤꯁ ꯏꯁ I1 ꯑꯃ ꯂꯧꯔꯅꯦꯕ ꯑꯗꯨꯑꯣꯏꯗꯤ U1 ꯄꯤꯔꯦ ꯁꯤꯗꯦꯟꯁꯤꯕꯨꯛꯁꯤ ꯀꯩ ꯑꯣꯏꯅꯤ ꯗꯤꯁ ꯏꯁ V1 ꯑꯣꯏꯒꯗ꯭ꯔꯥ ꯑꯣꯏꯔꯣꯏꯗ꯭ꯔꯥ V1 ꯑꯣꯏꯔꯅꯤ ꯑꯗꯨꯗꯤ ꯃꯣꯁ ꯀꯟꯚꯦꯟꯁꯅꯦꯜ ꯑꯣꯏꯕ ꯃꯌꯥꯝꯅ ꯍꯣꯠꯇꯣꯏꯁꯦ ꯀꯩ ꯍꯣꯠꯂꯅꯤꯁꯦ 1/f is equal to 1/U1 + 1/V1 ꯑꯃ ꯂꯥꯛꯀꯗ꯭ꯔꯥ ꯂꯥꯛꯑꯅꯤ ꯁꯤꯗꯒꯤ ꯀꯔꯤ ꯍꯣꯠꯂꯅꯤ ꯅꯪꯒꯤ V1 ꯍꯥꯟꯅ ꯍꯣꯠꯀꯗ꯭ꯔꯥ ꯍꯣꯠꯂꯣꯏꯗ꯭ꯔꯥ ꯑꯩ ꯍꯥꯏꯁꯤ ꯒ꯭ꯌꯥꯟ ꯇꯥꯍꯧꯕ꯭ꯔꯣ ꯇꯥꯍꯧꯗꯕ꯭ꯔꯣ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯕ ꯉꯝꯃꯤꯀꯣ ꯑꯗꯨ ꯁꯤ ꯚꯤꯁꯤ ꯑꯦꯐꯁꯤ ꯀꯩ ꯂꯥꯛꯑꯅꯤ 15 ꯑꯗꯨꯒ ꯁꯤꯁꯨ ꯀꯩ ꯂꯥꯛꯑꯅꯤ V1ꯁꯨ 15 ꯀꯩꯅꯣ ꯍꯣꯠꯂꯁꯤꯀꯣ ꯌꯦꯡꯉꯁꯤ ꯑꯦꯅꯤꯋꯦ ꯑꯩꯈꯣꯏ ꯍꯦꯛꯇ ꯍꯣꯠꯂꯒ ꯌꯦꯡꯁꯤꯀꯣ ꯁꯤꯗ ꯌꯦꯡꯉꯣ ꯑꯟꯁꯔꯅꯤꯀꯣ ꯁꯦ ꯗꯤꯁ ꯏꯁ ꯑꯟꯁꯔ ꯀꯟꯚꯦꯟꯁꯅꯦꯜ ꯋꯦ ꯑꯃꯒ ꯁꯣꯔꯠꯀꯠ ꯋꯦ ꯑꯃꯒ ꯇꯥꯛꯀꯦ ꯀꯟꯚꯦꯟꯁꯅꯦꯜ ꯋꯦꯒꯤꯗꯗꯤ ꯍꯤꯌꯔ 1/f ꯁꯤꯒꯤ ꯚꯦꯂꯨꯁꯤ ꯀꯌꯥꯅꯣꯁꯦ ꯃꯥ ꯄꯤꯖꯦ -15 ꯍꯥꯏꯗꯣꯏ ꯅꯠꯇ꯭ꯔꯥ ꯌꯨ ꯁꯨꯗ ꯇꯦꯛ ꯗ ꯁꯥꯏꯟ ꯀꯟꯚꯦꯟꯁꯟ -15 ꯑꯃ ꯍꯥꯞꯄꯅꯤ U1 ꯁꯤ ꯀꯌꯥꯅꯣ ꯃꯥ ꯄꯤꯔꯤꯁꯦ U1 ꯑꯣಬ್ꯖꯦꯛꯁꯤ ꯏꯅꯤꯁꯤꯌꯦꯜ ꯗꯤꯁꯇꯦꯟꯁꯁꯦ ꯀꯗꯥꯏ ꯂꯩꯔꯝꯃꯤ 40 ꯑꯃ ꯂꯥꯛꯄ ꯅꯠꯇ꯭ꯔꯥ ꯑꯗꯨꯗꯤ ꯗꯤꯁ ꯋꯤꯜ ꯕꯤ -40 ꯄ꯭ꯂꯁ ꯃꯊꯪꯗ 1/V1 ꯑꯃ ꯂꯥꯛꯀꯗ꯭ꯔꯥ ꯂꯥꯛꯏꯀꯣ ꯑꯗꯨ ꯌꯨ ꯖꯁ ꯇ꯭ꯔꯥꯟꯁꯐꯔ ꯑꯣꯚꯔ ꯍꯤꯌꯔ ꯗꯤꯁ ꯏꯁ 1/40 -1/15 1/V1 ꯈꯔꯕꯨꯗꯤ ꯁꯥꯡꯉꯦ ꯑꯦꯅꯤꯋꯦ ꯁꯥꯡꯖꯁꯅꯨ ꯃꯌꯥꯝꯅ ꯇꯧꯕꯗꯣ ꯑꯃꯨꯛꯇꯪ ꯌꯦꯡꯁꯤ ꯅꯪꯅ ꯎꯄꯥꯏ ꯂꯩꯇ ꯇꯥꯔꯗꯤ ꯁꯨꯃꯥꯏꯅ ꯍꯣꯠꯇꯣꯏꯅꯤ ꯗꯤꯁ ꯏꯁ 15 - 40 ꯗꯤꯁ ꯏꯁ 1/V1 ꯑꯃ ꯂꯥꯛꯇ꯭ꯔꯥ ꯑꯟꯁꯔ ꯋꯤꯜ ꯕꯤ ꯁꯤ ꯀꯌꯥ ꯇꯥꯏ answer will be value will be -25 tabra -25 divided by 40 into 15 this is 1/V1 this is 5 this is 8 5 3 adudi kya tare V1 ki value kya tare sir V1 will be equal to
-1/24
ha minus
-1/24
okay -1/24 laroi only 24 -24 centimeter am tadra adudi ngasai khoina haigibidu kai le answer do 15 daina 30 buk tagani dum taraba adudi ahanbagi magi object distance kya leire image distance V1 se kya tare V1 will be
-24
-24 leraba adi -24 lermina let me remove this simano remove tograge I1 ki value se kya tare this is kon require uri kya no V1 will be equal to 24 centimeter minus the ties in front lay haibane yabra yare ko next among second condition da mu lawrisi ko second condition je sida si leba natra mana sanggeli je kya sanggeli sidensi bukki hana kya lerambano sidensi bukki this is 30 m leramba natra this is 30 m
40
lerambane
sir 40 ꯅꯦ
40 ꯍꯥꯏꯕꯀꯣ ꯁꯣꯔꯤ this is 40 ꯑꯃ ꯂꯩꯔꯝꯕꯅꯦꯕ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ 40 ꯁꯤꯗꯒꯤ ꯃꯥꯅ 20 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯑꯃ ꯆꯪꯒꯦꯜꯂꯦ ꯍꯥꯏꯕ ꯅꯠꯇ꯭ꯔꯥ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯍꯤꯌꯔ ꯑꯣꯕꯖꯦꯛꯁꯤ ꯀꯔꯤ ꯂꯥꯛꯑꯅꯤ ꯑꯣꯕꯖꯦꯛ ꯗꯤꯁꯇꯦꯟꯁ U2 ꯑꯃ ꯍꯥꯏꯔꯒꯦ ꯁꯤ ꯃꯨꯠꯊꯠꯂꯒꯦꯀꯣ ꯑꯟꯗꯔꯁꯇꯦꯟ ꯇꯧꯅꯕ ꯑꯗꯨꯑꯣꯏꯗꯤ ꯍꯤꯌꯔ ꯗꯤꯁ ꯏꯁ ꯍꯟꯇꯛꯅ O2 ꯑꯃ ꯍꯥꯏꯔꯒꯦ O2 ꯁꯦ ꯀꯌꯥ ꯂꯥꯛꯄꯅꯤꯁꯦ ꯗꯤꯁ ꯏꯁ U2 ꯑꯃ ꯍꯥꯏꯔꯒꯦ ꯑꯣꯕꯖꯦꯛ ꯗꯤꯁꯇꯦꯟꯁ U2 is equal to -20 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯑꯃ ꯂꯩꯒꯗ꯭ꯔꯥ ꯂꯩꯔꯦ ꯑꯗꯨꯗꯤ ꯏꯃꯦꯖ ꯀꯗꯥꯏ ꯐꯣꯔꯝ ꯇꯧꯔꯅꯤ ꯏꯃꯦꯖ ꯋꯤꯜ ꯕꯤ ꯐꯣꯔꯝ ꯍꯤꯌꯔ ꯗꯤꯁ ꯏꯁ I2 ꯑꯃ ꯍꯥꯏꯔꯒꯦ ꯁꯤꯗ ꯅꯪ V2 ꯑꯃꯨꯛ ꯍꯣꯠꯀꯗ꯭ꯔꯥ ꯍꯣꯠꯂꯣꯏꯗ꯭ꯔꯥ we have to find out this V2 V2 find out ꯇꯧꯅꯕ very simple 1 by v equal to 1 by f minus 1 by u ꯑꯃ ꯂꯥꯛꯀꯗ꯭ꯔꯥ f ꯀꯤ ꯚꯦꯂꯨꯗꯤ ꯍꯣꯡꯗꯦꯀꯣ ꯑꯗꯨꯗꯤ -1/15 ꯃꯥꯏꯅꯁꯇꯣ ꯁꯨꯝ ꯃꯊꯛꯇ ꯍꯥꯞꯈ꯭ꯔꯕꯅꯤꯀꯣ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯕ ꯉꯝꯕ꯭ꯔꯥ ꯉꯝꯗꯕ꯭ꯔꯣ ꯃꯊꯛꯇ ꯆꯠꯈ꯭ꯔꯦꯀꯣ -1/u ꯒꯤ ꯚꯦꯂꯨꯁꯤ ꯀꯌꯥꯅꯣ ꯌꯨꯖꯤꯒꯤ ꯚꯦꯂꯨꯁꯤ 20 ꯑꯃ ꯂꯥꯛꯄ꯭ꯔꯥ 20 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯑꯗꯨꯗꯤ ꯃꯥꯏꯅꯁ ꯃꯥꯏꯅꯁ ꯑꯗꯨꯗꯤ ꯄ꯭ꯂꯁ ꯑꯃ ꯑꯣꯜꯂꯒꯦ ꯁꯝꯖꯜꯂꯒꯦ ꯍꯩꯒꯗ꯭ꯔꯥ ꯍꯩꯔꯣꯏꯗ꯭ꯔꯣ ꯍꯩꯅꯤꯀꯣ
ꯍꯥꯏꯅꯤ
ꯑꯗꯨ ꯁꯤꯗꯗꯤ ꯗꯤꯁ ꯏꯁ 15 ꯏꯟꯇꯨ 20 ꯑꯗꯨ ꯃꯥꯅ ꯁꯤ ꯂꯧ ꯇꯥꯔꯒꯗꯤ 15ꯒꯤꯗꯗꯤ -20 + 20ꯒꯤꯗꯗꯤ -15 ꯑꯟꯁꯔ ꯀꯌꯥ ꯇꯥꯔꯦ answer will be
-6
ꯑꯁꯤꯗ 5 ꯑꯃ ꯂꯩꯔꯦꯀꯣ ꯁꯤꯗꯗꯤ 15 ꯏꯟꯇꯨ 20 ꯑꯗꯨꯗꯤ ꯁꯤꯗ ꯗꯤꯁ ꯏꯁ 3
-60
60 -60 ꯇꯥꯔꯕ
-60
v2 is equal to -60 ꯑꯗꯨꯏꯗꯤ ꯃꯥꯒꯤ ꯂꯩꯔꯤꯕ ꯄꯣꯖꯤꯁꯟꯁꯦ ꯀꯌꯥ ꯂꯩꯔꯦ v2 is equal to -60 ꯑꯃ ꯂꯩꯔꯕ ꯑꯗꯨꯗꯤ ꯃꯥꯒꯤ ꯁꯤꯗꯩꯅ ꯁꯤꯕꯨꯛꯁꯦ from p ꯗꯩꯅ i1 ꯁꯦ ꯀꯌꯥꯅꯣ this is 24 and from p to i2 ꯁꯦ ꯀꯌꯥꯅꯣ it is 60 ꯂꯩꯇꯥꯔꯗꯤ our ꯀꯩ ꯑꯣꯏꯕ ꯇꯥꯔꯦ change in the image ꯄꯣꯖꯤꯁꯟꯁꯦ change in the image will be equal to very simple 60 minus kya lakpa 20 60 minus 24 answer will be 36 tabra option number B is our answer tare ko gyan tai khangi
ꯇꯥꯏ
adu sumaina holagadi yamna time consuming oidana time consuming oibanina let us go through the shortcut se mu holasi ꯅꯪꯅ ꯈꯪꯒꯗꯕꯁꯦ ꯁꯤꯗ ꯌꯦꯡꯉꯣ ꯁꯣꯔꯠꯀꯠ ꯈꯪꯅꯕꯒꯤꯗꯃꯛꯇ ꯅꯦꯛꯁꯀꯤ ꯐꯣꯔꯃꯨꯂꯥꯁꯤꯃ ꯈꯪꯕ ꯃꯊꯧ ꯇꯥꯏ ꯗꯦꯠ ꯏꯁ ꯅꯪꯒꯤ ꯂꯦꯇꯔꯦꯜ ꯃꯦഗ്ꯅꯤꯐꯤꯀꯦꯁꯟ ꯈꯪꯈ꯭ꯔꯦ ꯂꯤꯅꯤꯌꯔ ꯃꯦग्ꯅꯤꯐꯤꯀꯦꯁꯟ ꯈꯪꯉꯦꯀꯣ ꯃꯃꯤꯡꯁꯤ ꯈꯪꯒꯗꯕꯅꯤꯀꯣ ꯇ꯭ꯔꯥꯟꯁꯚꯔꯁ ꯂꯦꯇꯔꯦꯜ ꯑꯣꯔ ꯂꯤꯅꯤꯌꯔ ꯃꯣꯏꯁꯦ ꯑꯃꯈꯛ ꯑꯣꯏꯒꯗꯕ ꯂꯣꯡꯒꯤꯇ꯭ꯌꯨꯗꯅꯦꯜ ꯃꯦग्ꯅꯤꯐꯤꯀꯦꯁꯟ ꯑꯃ ꯍꯥꯏꯒꯗꯕ ꯂꯣꯡꯒꯤꯇ꯭ꯌꯨꯗꯅꯦꯜ ꯃꯦഗ്ꯅꯤꯐꯤꯀꯦꯁꯟꯁꯦ ꯀꯔꯤꯒ ꯃꯥꯟꯅꯒꯦ ꯍꯥꯏꯇꯥꯔꯗꯤ ꯗꯤꯁ ꯏꯁ ꯁꯤꯗ ꯑꯩꯅ ꯌꯦꯛꯕ ꯗꯥꯏꯒ꯭ꯔꯥꯝꯁꯦ ꯎꯕ꯭ꯔꯥ ꯐꯣꯔꯃꯨꯂꯥꯒꯤ ꯗꯥꯏꯒ꯭ꯔꯥꯝꯁꯤꯗ ꯀꯔꯤ ꯍꯥꯏ ꯀꯔꯤ ꯑꯣꯏꯅ ꯎꯔꯦ ꯑꯣꯕꯖꯦꯛꯁꯦ ꯀꯩ when the object is placed horizontally along the principal axis ꯁꯨꯃꯥꯏꯅ ꯍꯣꯔꯥꯏꯖꯟꯇꯦꯜ ꯑꯣꯏꯅ ꯊꯝꯕ ꯇꯥꯔꯗꯤ ꯀꯃꯥꯏꯅ ꯇꯧꯔꯁꯦ the image the magnification from will be ꯀꯩ ꯑꯣꯏꯒꯅꯤ ꯁꯦ length of the ꯀꯅꯥ ꯑꯣꯏꯕꯁꯦ length of the image divided by this is length of the image divided by length of the object that is our करी होगनी longitudinal magnification will be equal to m square into कना होगिदिनो से m square का मानागदब याब्रा अइन हनी अथरदि अतै नतेको how will you define longitudinal magnification will be defined as length of image divided by length of object and this will be represented as delta v divided by delta u and this value will be equal to m square nang na sinadisi kayo na hapani the change in the image position gyanday ko divided by change in the object position will be equal to kanaga managani nangi linear magnification gi square ga managani gyantabra understood tawung ngam ꯉꯝꯃꯤꯀꯣ ꯑꯗꯨꯗꯤ ꯁꯤꯗ ꯌꯦꯡꯉꯣ ꯑꯦꯛꯖꯥꯝꯄꯜ ꯑꯣꯏꯅ ꯂꯧꯁꯤ ꯁꯤꯗ ꯅꯪꯅ ꯑꯣꯕꯖꯦꯛꯁꯦ U1 ꯑꯃ ꯂꯩꯔꯝꯃꯦ ꯈꯜꯂꯁꯦꯕꯀꯣ ꯗꯤꯁ ꯏꯁ ꯑꯣꯕꯖꯦꯛ U1 ꯂꯩꯔꯝꯃꯦ ꯑꯗꯨꯗꯤ ꯃꯥꯒꯤ ꯏꯃꯦꯖꯁꯦ ꯁꯤꯗ ꯏꯃꯦꯖꯁꯦ ꯀꯗꯥꯏ ꯐꯣꯔꯝ ꯇꯧꯔꯤꯁꯦ V1 ꯑꯃ ꯂꯩꯔꯕ ꯑꯗꯨꯒ ꯑꯣꯕꯖꯦꯛꯁꯦ ꯀꯩꯗꯧꯏ ꯑꯣꯕꯖꯦꯛ ꯃꯨꯚ ꯑꯋꯦ ꯐ꯭ꯔꯣꯝ ꯗ ꯃꯤꯔꯔꯗꯩ ꯆꯠꯊꯣꯛꯈꯤꯕ ꯇꯥꯔꯗꯤ ꯏꯃꯦꯖꯁꯦ ꯑꯃꯨꯛ ꯁꯣꯝ ꯅꯥꯀꯟ ꯆꯪꯁꯤꯜꯂꯛꯀꯗ꯭ꯔꯥ ꯆꯪꯁꯤꯜꯂꯣꯏꯗ꯭ꯔꯥ ꯆꯪꯁꯤꯜꯂꯛꯑꯦ ꯑꯗꯨꯗꯤ we can say that the person is changing its position from U1 to U2 at the same time kana aurani se the image position also change to v1 to v2 change tawdabra tawi adu idi khoina sigi concept se nangi question number 1 da apply tawbo yabra yadabra ai haise khangobra khangi ko ꯑꯗꯨꯗꯤ ꯉꯁꯥꯏ ꯃꯥꯅ ꯁꯤꯗ ꯂꯩꯔꯝꯕꯁꯦ ꯀꯩ ꯂꯩꯔꯝꯃꯤ ꯃꯥꯒꯤ ꯑꯣꯕꯖꯦꯛ ꯄꯣꯖꯤꯁꯟ O1 ꯗꯒꯤ ꯑꯣꯕꯖꯦꯛ ꯄꯣꯖꯤꯁꯟ O2 ꯗ ꯍꯣꯡꯕ꯭ꯔꯥ ꯑꯗꯨꯗꯤ ꯃꯁꯤ ꯗꯦꯜꯇꯥ ꯌꯨꯅꯦꯅ ꯈꯟꯕꯤꯔꯣ ꯑꯗꯨꯒ ꯅꯦꯛꯁ ꯑꯅꯤꯁꯨꯕꯁꯤꯅ ꯀꯩ ꯂꯥꯛꯑꯅꯤ ꯁꯤꯁꯤꯅ ꯀꯩ ꯂꯥꯛꯑꯅꯤ ꯗꯦꯜꯇꯥ ꯚꯤ ꯑꯃ ꯅꯠꯇ꯭ꯔꯥ ꯑꯗꯨꯗꯤ ꯗꯦꯜꯇꯥ ꯚꯤ ꯄꯨꯊꯣꯛꯑꯕꯅꯤ ꯑꯗꯨꯗꯤ ꯗꯦꯜꯇꯥ ꯚꯤ ꯈꯪꯒꯦꯗꯤ ꯌꯨ ꯖꯁ ꯍꯦꯞ ꯇꯨ ꯅꯣ ꯗ ꯂꯤꯅꯤꯌꯔ ꯃꯦग्ꯅꯤꯐꯤꯀꯦꯁꯟ ꯈꯪꯉꯗꯤ ꯌꯥꯒꯗ꯭ꯔꯥ ꯌꯥꯔꯅꯤ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯕ ꯉꯝꯃꯤꯀꯣ ꯑꯗꯨꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯑꯍꯥꯟꯕ ꯀꯟꯗꯤꯁꯟꯁꯤꯗ ꯀꯣꯏꯁꯟ ꯅꯝꯕꯔ 1ꯒꯤ ꯑꯟꯁꯔꯗ ꯌꯦꯡꯉꯣ ꯃꯥꯅ ꯄꯤꯔꯝꯕ ꯄꯣꯖꯤꯁꯟꯗꯣ ꯑꯗꯨ ꯈꯛꯇꯪ ꯍꯥꯟꯅ ꯍꯣꯠꯄꯤꯔꯣꯕꯀꯣ ꯑꯣब्ꯖꯦꯛ I1ꯒ I2ꯒꯤꯗ ꯍꯣꯠꯂꯣ ꯗꯤꯁ ꯏꯁ ꯐꯣꯀꯁ ꯌꯥꯏꯀꯣ ꯁꯤꯅ ꯗꯤꯁ ꯏꯁ ꯁꯦꯟꯇꯔ ꯑꯣꯐ ꯀꯔꯚꯦꯆꯔ ꯁꯤꯅ ꯀꯩ ꯂꯥꯛꯀꯅꯤ ꯑꯣꯕꯖꯦꯛ O1 ꯃꯥꯒꯤ ꯗꯤꯁꯇꯦꯟꯁꯁꯦ ꯀꯌꯥ ꯂꯥꯞꯄꯤ ꯃꯥꯒꯤ ꯗꯤꯁꯇꯦꯟꯁꯁꯦ 40 ꯂꯥꯞꯄ꯭ꯔꯥ ꯂꯥꯞꯄꯤꯀꯣ ꯑꯗꯨꯗꯤ ꯗꯤꯁ ꯏꯁ 40 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯑꯃ ꯂꯧꯔꯣ ꯌꯥꯔꯦ ꯑꯗꯨꯒ ꯁꯤꯅ ꯀꯌꯥ ꯑꯣꯏꯔꯦ ꯗꯤꯁ ꯏꯁ
15.
15 ꯑꯃ ꯂꯥꯛꯄ꯭ꯔꯥ
Mm.
ꯁꯤ 15 ꯑꯃ ꯂꯥꯛꯏꯀꯣ ꯁꯦ ꯗꯤꯁ ꯏꯁ 15 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯑꯗꯨ ꯑꯣꯏꯗꯤ ꯅꯪꯅ ꯄꯤꯔꯝꯃꯤꯁꯦ F ꯄꯤꯔꯦ U ꯄꯤꯔꯦ ꯚꯦꯔꯤ ꯁꯤꯝꯄꯜ ꯅꯪ ꯌꯨꯒ ꯑꯦꯐꯀ ꯄꯤꯔꯝ ꯇꯥꯔꯗꯤ ꯌꯨ ꯀꯦꯟ ꯀꯥꯜꯀꯨꯂꯦꯠ ꯗ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯄ꯭ꯔꯗ꯭ꯌꯨꯁ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯁꯦ U1 is equal to minus 40 ꯑꯃ ꯂꯥꯛꯄ ꯅꯠꯇ꯭ꯔꯥ ꯁꯤꯅ ꯀꯩ ꯍꯥꯞꯅꯤꯁꯦ ꯗꯤꯁ ꯏꯁ F ꯑꯃ ꯍꯥꯞꯄꯣ ꯗꯤꯁ ꯏꯁ F equal to ꯅꯪꯒꯤ -15 ꯌꯥꯏꯀꯣ ꯑꯟꯗꯔꯁꯇꯨꯠ ꯇꯧꯕ ꯉꯝꯃꯤꯀꯣ ꯁꯦ ꯑꯗꯨꯏꯗꯤ ꯍꯤꯌꯔ ꯂꯤꯅꯤꯌꯔ ꯃꯦग्ꯅꯤꯐꯤꯀꯦꯁꯟ M will be equal to very simple ꯀꯃꯥꯏꯅ ꯍꯣꯠꯄ ꯇꯥꯔꯦ ꯅꯪꯒꯤ F divided by F minus U ꯁꯤ ꯍꯣꯠꯄ ꯌꯥꯕ꯭ꯔꯥ ꯒ꯭ꯌꯥꯟ ꯇꯥꯏꯀꯣ ꯑꯗꯨ F ꯀꯤ ꯀꯌꯥ ꯂꯥꯛꯑꯅꯤ -15 divided by ꯅꯪꯒꯤ -15 ꯑꯗꯨꯒ minus of -40 ꯑꯗꯨ ꯀꯥꯜꯀꯨꯂꯦꯠ ꯇꯧꯔꯣ ꯃꯥꯒꯤ ꯀꯌꯥ ꯇꯥꯕ -15 divided by ꯁꯤꯗꯗꯤ ꯀꯌꯥ ꯇꯥ ꯄ꯭ꯂꯁ ꯂꯥꯛꯄ꯭ꯔꯥ ꯑꯗꯨ 35 ꯑꯃ ꯊꯝꯕ ꯌꯥꯕ꯭ꯔꯣ ꯅꯠꯇꯦ 25 ꯑꯣꯏꯗꯤ ꯑꯣꯏꯔꯝꯒꯅꯤꯀꯣ 25 + 25 ꯑꯣꯏꯔꯦꯀꯣ ꯍꯥꯏꯕꯗꯤ +40 15 ꯈꯥꯏꯗꯣꯛꯈꯤ ꯇꯥꯔꯗꯤ 25 ꯇꯥꯔꯦꯀꯣ 5ꯅ ꯀꯠ ꯇꯧ ꯇꯥꯔꯗꯤ ꯁꯤ ꯀꯌꯥ ꯇꯥꯔꯅꯤ 3
3
5
by
ꯑꯗꯨꯒꯤ
5.
ꯑꯟꯁꯔꯗ -3/5 ꯑꯃ ꯇꯥꯔꯕ ꯑꯗꯨꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯈꯪꯉꯤꯁꯤ ꯀꯩ ꯈꯪꯉꯤ ꯂꯤꯅꯤꯌꯔ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯈꯪꯉꯕ ꯈꯪꯉꯤꯀꯣ ꯑꯗꯨꯗꯤ ꯌꯦꯡꯉꯣ ꯅꯪꯒꯤ ꯆꯦꯟꯁꯤꯗ ꯑꯣꯕꯖꯦꯛ ꯄꯣꯖꯤꯁꯟꯗꯤ ꯀꯌꯥꯒ ꯃꯥꯟꯅꯩ ꯄꯤꯔꯝꯃꯤ ꯗꯦꯜꯇꯥ ꯌꯨꯁꯤ ꯀꯌꯥ ꯄꯤꯔꯝꯃꯤ ꯍꯥꯟꯅ 40 ꯂꯩꯔꯝꯕꯗꯒꯤ ꯀꯌꯥꯗ ꯆꯦꯟꯖ ꯇꯧꯈꯤ 20ꯗ ꯆꯦꯟꯖ ꯇꯧꯈꯤꯕ꯭ꯔꯥ ꯇꯧꯗꯕ꯭ꯔꯥ ꯑꯗꯨꯗꯤ
Mm.
ꯀꯌꯥ ꯂꯦꯝꯍꯧꯔꯦ ꯗꯤꯁ ꯏꯁ 20 ꯑꯃ ꯂꯦꯝꯕ꯭ꯔꯥ ꯂꯦꯝꯗꯕ꯭ꯔꯣ ꯑꯩ ꯍꯥꯏꯁꯦ ꯈꯪꯍꯧꯕ꯭ꯔꯣ ꯈꯪꯍꯧꯗꯕ꯭ꯔꯣ O1ꯗꯒꯤꯅ
ꯈꯪꯉꯦ
O2
ꯁꯥꯔ
ꯑꯃꯁꯤ ꯂꯥꯛꯄ꯭ꯔꯥ ꯂꯥꯛꯇꯕ꯭ꯔꯣ ꯑꯗꯩ ꯃꯥꯒꯤ ꯚꯦꯂꯨꯁꯤ ꯀꯌꯥꯅꯣ ꯗꯤꯁ ꯏꯁ U2 is equal to only 20 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯅꯠꯇ꯭ꯔꯥ -20
Mm.
ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯑꯗꯨ ꯆꯦꯟꯁꯤꯡꯗ ꯑꯣꯕꯖꯦꯛ ꯄꯣꯖꯤꯁꯟ ꯍꯥꯏꯗꯤ ꯗꯦꯜꯇꯥ ꯌꯨꯁꯦ ꯗꯦꯜꯇꯥ ꯌꯨ ꯏꯁ ꯒꯤꯚꯟ ꯑꯦꯁ 20 ꯑꯃ ꯇꯥꯔꯕ ꯇꯥꯔꯦ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯗꯦꯜꯇꯥ ꯚꯤ ꯄꯨꯊꯣꯛꯀꯦ ꯚꯦꯔꯤ ꯁꯤꯝꯄꯜ ꯗꯦꯜꯇꯥ ꯚꯤ ꯕꯥꯏ longitudinal magnification M longitudinal this is equal to delta V by U is equal to M square ꯑꯃ ꯂꯥꯛꯄ꯭ꯔꯥ ꯂꯥꯛꯑꯦ ꯑꯗꯨꯗꯤ delta V is equal to M square into delta U ꯑꯃ ꯍꯥꯞꯄꯤꯔꯣ M square ꯗꯤ ꯀꯌꯥꯅꯣꯁꯦ ꯃꯥꯏꯅꯁꯁꯦ ꯃꯥꯡꯈ꯭ꯔꯅꯤ ꯑꯗꯨꯗꯤ this is 9 divided by 25 into ꯍꯟꯗꯛꯇꯤ ꯁꯤꯁꯤ 20 ꯑꯅ ꯏꯕ ꯌꯥꯕ꯭ꯔꯥ ꯌꯥꯔꯦ ꯌꯥꯏꯀꯣ ꯑꯗꯨꯗꯤ
Ah.
3/25 ꯗꯦꯜꯇꯥ ꯌꯨꯁꯤ ꯀꯩꯅꯣ ꯆꯦꯟꯁꯤꯟꯗ ꯑꯣꯕꯖꯦꯛ ꯄꯣꯖꯤꯁꯟꯁꯦ 20 ꯑꯃ ꯂꯥꯛꯄ ꯅꯠꯇ꯭ꯔꯥ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ 24 ꯑꯁꯤꯅ ꯀꯩ ꯂꯥꯛꯄ 5 ꯑꯩꯒꯤ ꯀꯥꯜꯀꯨꯂꯦꯁꯟꯁꯦ ꯀꯗꯥꯏꯗ
6
ꯁꯣꯏꯈ꯭ꯔꯦ
by 5.
36/5 ꯂꯥꯛꯄ꯭ꯔꯥ
Mm.
ꯑꯟꯁꯔꯗꯤ 36 ꯇꯥꯒꯗꯕ ꯅꯠꯇ꯭ꯔꯣ ꯑꯗꯨꯗꯤ 5ꯁꯦ ꯀꯗꯥꯏꯗ ꯑꯃ ꯆꯦꯟꯅꯈ꯭ꯔꯦ ꯉꯥꯏꯈꯣꯀꯣ ꯑꯩ ꯀꯩꯅꯣꯝꯇ ꯌꯦꯡꯒꯦ ꯁꯤꯗ ꯂꯩꯕ ꯐꯣꯔꯃꯨꯂꯥꯁꯦ ꯆꯨꯝꯃꯤꯕ ꯆꯥꯂꯥ ꯑꯝꯇ ꯆꯦꯛ ꯇꯧꯁꯤꯀꯣ -U ꯑꯁꯤ ꯂꯩꯕꯁꯦꯀꯣ ꯑꯗꯨꯑꯣꯏꯗꯤ F - U ꯑꯗꯨꯒ M square F ꯁꯤ ꯀꯌꯥꯅꯣ ꯃꯥ ꯄꯤ ꯐꯣꯀꯦꯜ ꯂꯦꯡ 15 ꯄꯤꯕ ꯅꯠꯇ꯭ꯔꯣ ꯐꯣꯀꯦꯜ ꯂꯦꯡ ꯏꯁ 15 ꯑꯗꯨꯗꯤ 15 ꯑꯗꯨꯗꯤ 40ꯗꯒꯤ 15 25 ꯂꯥꯛꯄꯀꯣ 5 3 5 ꯆꯨꯝꯃꯤꯅꯦ ꯑꯗꯨꯒ ꯏꯃꯦꯖ 20 ꯑꯗꯨꯒ 36/5 5 ꯁꯤꯃ ꯐꯔꯛ ꯇꯥ ꯂꯩꯔꯦ ꯈꯪꯗꯤ ꯈꯪꯉꯤꯀꯣ ꯑꯩꯅ ꯇꯥꯛꯏꯕꯁꯦ ꯈꯪꯉꯤꯀꯣ
ꯑꯧ ꯈꯪꯉꯦ
ꯉꯥꯏꯈꯣꯀꯣ ꯑꯃꯨꯛꯇꯪ ꯑꯩ ꯀꯥꯜꯀꯨꯂꯦꯁꯟꯁꯦ ꯀꯗꯥꯏꯗ ꯁꯣꯏꯒꯦꯗ ꯑꯝꯇ ꯆꯦꯛ ꯇꯧꯒꯦ ꯑꯟꯁꯔꯗꯤ 36 ꯇꯥꯕꯀꯣ ꯑꯩ ꯁꯣꯔꯠꯀꯠꯁꯤꯗ ꯀꯥꯏꯗꯅ ꯑꯃ ꯁꯣꯏꯈ꯭ꯔꯦ ꯎꯝ -15 E1ꯒꯤ 40 E1ꯁꯤ ꯀꯥꯏꯅ ꯃꯥ 40 ꯍꯥꯏꯕꯅꯦꯕꯀꯣ displaced through 20 centimeter towards the mirror 20 ꯍꯥꯏꯕꯅꯦꯕ ꯑꯗꯨ 20 ꯑꯦꯅꯤꯋꯦ ꯑꯗꯣ ꯑꯪꯀ ꯍꯣꯠꯄꯒꯤ ꯅꯤꯌꯣꯝꯁꯦ ꯁꯨꯃꯥꯏꯅ ꯍꯣꯠꯀꯗꯕꯅꯤꯀꯣ ꯑꯁꯤꯗ ꯑꯩ ꯁꯣꯔꯠꯀꯠ ꯄꯥꯟꯕꯁꯤꯗ ꯇꯥꯗ꯭ꯔꯦ 5 ꯑꯃ ꯍꯦꯟꯖꯤꯟ ꯊꯣꯛꯈ꯭ꯔꯦ ꯀꯣ 5 ꯇꯧ ꯇꯥꯔꯗꯤ 5×5 = 25 36/5 ꯑꯦꯅꯤꯋꯦ ꯑꯗꯣ ꯅꯪ ꯍꯩꯗꯤ ꯍꯩꯒꯗ꯭ꯔꯕ ꯁꯤ ꯍꯣꯠꯄꯒꯤ ꯅꯤꯌꯣꯝꯁꯦ ꯈꯪꯅꯤꯀꯣ ꯑꯗꯨꯗꯤ ꯇꯨꯁꯦ 20 ꯑꯃ ꯂꯩꯕꯅꯦ ꯀꯩꯅꯣꯝꯇ ꯌꯦꯡꯒꯦ ꯗꯦꯜꯇꯥ ꯌꯨꯁꯦ 20 ꯆꯦꯟꯖ ꯏꯟ ꯄꯣꯖꯤꯁꯟ 20 ꯑꯃ ꯂꯩꯔꯦꯀꯣ ꯑꯗꯨꯗꯤ ꯑꯣꯞꯖꯦꯛ ꯄꯣꯖꯤꯁꯟꯁꯦ ꯍꯣꯡꯐꯝꯗꯤ ꯊꯣꯛꯄ ꯑꯦꯅꯤꯋꯦ ꯃꯁꯤ ꯁꯨꯃꯥꯏꯅ ꯅꯪꯅ ꯍꯣꯠꯄꯗ ꯑꯪꯀꯁꯦ ꯇꯥꯗ꯭ꯔꯒꯁꯨ ꯉꯁꯥꯏꯒꯤ ꯀꯟꯚꯦꯟꯁꯟ ꯃꯦꯊꯠꯇ ꯍꯣꯠꯂꯁꯨ ꯑꯗꯨꯝ ꯇꯥꯗꯤ ꯇꯥꯏꯀꯣ ꯁꯦ ꯌꯥꯒꯗ꯭ꯔꯥ ꯈꯪꯉꯤ ꯑꯗꯨꯗꯤ ꯂꯥꯁ ꯀꯣꯏꯁꯟ ꯀꯣꯏꯁꯟ ꯅꯝꯕꯔ 3ꯁꯦ ꯑꯁꯤꯝꯇꯪꯒ ꯍꯣꯠꯁꯦ ꯑꯗꯨꯒ ꯂꯣꯏꯁꯟꯁꯤ ꯑꯩ ꯍꯣꯔꯦꯟ ꯑꯃꯨꯛ ꯆꯦꯛ ꯇꯧꯒꯦꯕꯀꯣ ꯁꯦ ꯃꯔꯛꯁꯤꯗ ꯀꯃꯥꯏꯅ ꯂꯥꯜꯂꯤꯅꯣꯗꯣ ꯌꯦꯡꯉꯣ ꯀꯣꯏꯁꯟ ꯅꯝꯕꯔ 3ꯁꯤꯗ ꯑꯟꯁꯔꯁꯦ ꯀꯌꯥ ꯇꯥꯗꯒꯦ ꯌꯦꯡꯉꯣ ꯀꯣꯏꯁꯟ ꯅꯝꯕꯔ 3ꯁꯦ match the corresponding entries of column 1 with column 2 where m is the magnification produced ꯑꯗꯨꯗꯤ ꯁꯤꯝꯄꯜ ꯑꯣꯏꯅ ꯑꯝꯇꯪ ꯍꯥꯏꯔꯁꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯁꯦ -2 ꯑꯃ ꯂꯩꯔꯦꯀꯣ ꯑꯍꯥꯟꯕꯗ ꯁꯤ ꯀꯩꯅꯣ ꯍꯥꯟꯅ ꯍꯣꯠꯁꯤ -2 ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯁꯤ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯂꯥꯏꯕꯁꯤ ꯌꯦꯡꯉꯣ ꯑꯦꯁꯦ ꯀꯅꯥꯒ ꯀꯝꯄꯦꯌꯔ ꯇꯧꯅꯤ ꯑꯝꯇ ꯍꯥꯏꯔꯛꯑꯣ ꯈ꯭ꯋꯥꯏ ꯂꯥꯏꯕ ꯍꯥꯟꯅ ꯍꯧꯁꯤꯁꯦ ꯁꯤꯗ ꯍꯥꯟꯅ ꯍꯧꯁꯤ ꯁꯤꯁꯦ ꯀꯔꯝꯕ ꯃꯤꯔꯔ ꯑꯣꯏꯅꯤ
ꯑꯗꯨꯗꯣ ꯀꯟꯚꯦꯛꯁ
ꯍꯥ
ꯄꯣꯖꯤꯇꯤꯚ ꯀꯟꯚꯦꯛꯁ
ꯀꯟꯚꯦꯛꯁ
ꯄꯣꯖꯤꯇꯤꯚ
ꯆꯨꯝꯒꯗ꯭ꯔꯥꯅꯦ ꯀꯟꯚꯦꯛꯁꯀꯤꯗꯗꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯏꯁ ꯑꯣꯜꯋꯦꯁ ꯂꯦꯁ ꯗꯦꯟ 1 ꯀꯟꯚꯦꯛꯁꯇꯤ ꯃꯥ ꯗꯤꯃꯤꯅꯤꯁ ꯇꯧꯕ ꯐꯣꯔꯝ ꯇꯧꯔꯤꯗꯨꯗꯤ ꯅꯪꯅ ꯀꯥꯎꯔꯤꯁꯤ ꯀꯩ ꯀꯥꯎꯕ ꯌꯥꯗꯦꯕ ꯀꯟꯀꯦꯞ ꯑꯣꯏꯒꯗꯣꯏ ꯅꯠꯇ꯭ꯔꯣ ꯒ꯭ꯌꯥꯟ ꯇꯥꯕ꯭ꯔꯣ ꯑꯩ ꯍꯥꯏꯁꯤ ꯈꯪꯍꯧꯕ꯭ꯔꯥ ꯈꯪꯍꯧꯗꯕ꯭ꯔꯥ ꯀꯟꯀꯦꯞꯇ ꯃꯦꯒꯅꯤꯐꯥꯏ ꯇꯧꯕ꯭ꯔꯥ ꯇꯧꯗꯕ꯭ꯔꯥ ꯌꯦꯡꯉꯨꯁꯦ ꯀꯔꯤꯒꯨꯝꯕ ꯋꯦꯟ ꯑꯦꯚꯔ ꯗ ꯑꯣꯕꯖꯦꯛ ꯏꯁ ꯄ꯭ꯂꯦꯁ ꯕꯤꯇ꯭ꯋꯤꯟ ꯅꯪꯒꯤ ꯐꯣꯀꯁ ꯑꯦꯟ ꯄꯣꯜ ꯐꯣꯀꯁꯀꯤ ꯄꯣꯜ ꯃꯔꯛꯇ ꯐꯣꯔꯝ ꯇꯧꯕ ꯃꯇꯝꯗ ꯏꯃꯦꯖꯁꯦ ꯃꯦꯒꯅꯤꯐꯥꯏꯠ ꯑꯣꯏꯕ꯭ꯔꯥ ꯑꯣꯏꯗꯕ꯭ꯔꯣ ꯗꯤꯁ ꯏꯁ 2 ꯁꯦꯟꯇꯤꯃꯤꯇꯔꯅꯦꯅ ꯈꯜꯂꯣ ꯗꯤꯁ ꯏꯁ 4 ꯁꯦꯟꯇꯤꯃꯤꯇꯔ ꯑꯗꯨꯗꯤ ꯃꯥꯒꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯁꯦ ꯀꯌꯥ ꯑꯣꯏꯔꯅꯤ ꯁꯥꯏꯖ ꯑꯣꯐ ꯗ ꯑꯣꯕꯖꯦꯛ ꯗꯦꯠ ꯏꯁ 4 size of the image that is 4 size of the object that is 2 answer +2 ꯇꯥꯕ꯭ꯔꯥ ꯇꯥꯗꯕ꯭ꯔꯥ ꯒ꯭ꯌꯥꯟ ꯇꯥꯕ꯭ꯔꯥ ꯇꯥꯗꯕ꯭ꯔꯥ ꯑꯩ ꯉꯥꯡꯉꯤꯁꯦ ꯈꯪꯉꯅꯤꯀꯣ
ꯇꯥꯏ
ꯑꯗꯩ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯗ if the value of the magnification is positive and it is more than 1 ꯑꯗꯨ ꯀꯅꯥ ꯑꯣꯏꯒꯅꯤ it will be concave ꯑꯣꯏꯒꯗꯕ ꯌꯥꯒꯗ꯭ꯔꯥ ꯌꯥꯔꯣꯏꯗ꯭ꯔꯥ ꯅꯪꯅ ꯚꯔꯆꯨꯋꯦꯜ ꯏꯃꯦꯖꯀꯤ ꯃꯇꯝꯁꯤꯗꯗꯤꯅꯦ ꯅꯪꯅ ꯀꯥꯎꯔꯣꯏꯗꯕꯁꯦ ꯋꯤ ꯍꯦꯚ ꯅꯪꯒꯤ ꯄꯣꯖꯤꯕꯜꯁꯦ ꯁꯤ ꯂꯣꯏꯅꯃꯛ ꯑꯣꯏꯕ ꯌꯥꯏ ꯒ꯭ꯌꯥꯟ ꯇꯥꯕ꯭ꯔꯥ ꯏꯠ ꯃꯦ ꯕꯤ ꯄ꯭ꯂꯦꯟ ꯃꯤꯔꯔ ꯑꯣꯏꯕ ꯌꯥꯏ ꯏꯠ ꯃꯦ ꯕꯤ ꯀꯩꯅꯣ ꯑꯣꯏꯕ ꯌꯥꯏ ꯀꯟꯚꯦꯛꯁ ꯑꯣꯏꯕ ꯌꯥꯏ ꯏꯠ ꯃꯦ ꯕꯤ ꯀꯟꯀꯦꯞ ꯑꯣꯏꯕ ꯌꯥꯏ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯈꯛꯀꯤꯗꯗꯤ ꯀꯩ ꯑꯣꯏꯔꯅꯤ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖꯇꯗꯤ ꯏꯠ ꯋꯤꯜ ꯕꯤ ꯑꯣꯡꯂꯤ ꯅꯪꯒꯤ ꯀꯟꯅꯥ ꯇꯥꯗꯣꯏꯅꯣꯁꯦ ꯀꯟꯀꯦꯞ ꯀꯟꯀꯦꯞ ꯇꯥꯗꯣꯏꯔꯣ ꯇꯥꯔꯣꯏꯗ꯭ꯔꯣ ꯇꯥꯔꯅꯤ ꯌꯥꯔꯅꯤꯀꯣ ꯁꯦ ꯑꯗꯨꯗꯤ ꯅꯦꯛꯁꯇ ꯑꯃꯨꯛ ꯌꯦꯡꯉꯣꯁꯦ ꯃꯥꯅ ꯑꯁꯤꯒꯤ ꯑꯣꯞꯁꯟꯁꯤꯒꯤ ꯃꯇꯨꯡ ꯏꯟꯅ ꯅꯣꯏ ꯀꯟꯐ꯭ꯌꯨꯁ ꯆꯠꯍꯜꯂꯤꯅꯤꯀꯣ ꯁꯤꯗꯤ ꯀꯩ ꯑꯣꯏꯔꯅꯤꯁꯦ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟꯁꯦ ꯄ꯭ꯂꯁ ꯍꯥꯞ ꯑꯃ ꯂꯩꯔꯦꯀꯣ ꯄ꯭ꯂꯁ ꯍꯥꯞ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯂꯦꯁ ꯗꯦꯟ ꯋꯥꯟ ꯑꯣꯏꯔꯦ ꯑꯗꯨꯗꯤ ꯃꯥꯁꯦ ꯀꯔꯝꯕ ꯑꯣꯏꯔꯅꯤ ꯁꯦ ꯗꯤꯁ ꯋꯤꯜ ꯕꯤ ꯌꯣꯔ ꯀꯟꯚꯦꯛꯁ ꯃꯤꯔꯔ ꯑꯃ ꯇꯥꯒꯗ꯭ꯔꯥ ꯇꯥꯔꯅꯤ ꯑꯗꯨꯒ ꯃꯥꯏꯅꯁ ꯇꯨꯁꯤ ꯀꯔꯤ ꯑꯣꯏꯕ ꯇꯥꯔꯦ ꯃꯥꯏꯅꯁ ꯇꯨ ꯋꯤꯜ ꯕꯤ ꯃꯥꯏꯅꯁ ꯑꯣꯏꯗꯤ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯑꯣꯏꯒꯗ꯭ꯔꯥ ꯑꯣꯏꯔꯣꯏꯗ꯭ꯔꯥ
ꯔꯤꯌꯦꯜ
ꯎꯝ ꯃꯥꯏꯅꯁ ꯇꯨꯁꯦ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯑꯃ ꯇꯥꯔꯦ ꯌꯥꯗ꯭ꯔꯥ ꯆꯥꯎꯈꯠꯂꯛꯏꯅꯦꯕꯀꯣ ꯁꯤ ꯌꯥꯏꯑꯕ ꯑꯗꯨꯒ ꯃꯥꯏꯅꯁ ꯃꯥꯏꯅꯁ ꯍꯥꯏꯕ ꯗꯤꯃꯤꯅꯤꯁ ꯑꯣꯏꯗꯣꯏꯅꯦꯕ ꯑꯁꯤꯁꯨ ꯀꯩ ꯑꯣꯏꯒꯅꯤ ꯅꯪꯒꯤ ꯀꯟꯚꯦꯛꯁ ꯌꯦꯡꯁꯤ ꯃꯥꯅ ꯑꯣꯞꯁꯟꯁꯤꯗ ꯆꯨꯝꯕ ꯃꯌꯥꯝ ꯄꯤꯔꯝꯃꯤꯀꯣ ꯍꯥꯏꯗꯤ ꯅꯪꯒꯤ ꯁꯤꯒꯤ ꯅꯝꯕꯔ ꯕꯤꯁꯦ ꯀꯟꯚꯦꯛꯁ ꯃꯤꯔꯔ ꯑꯣꯏꯔꯁꯨ ꯌꯥꯏ ꯅꯠꯇ꯭ꯔꯒ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯑꯣꯏꯔꯁꯨ ꯌꯥꯏ ꯃꯥꯏꯅꯁ ꯄꯤꯕꯅꯤꯅ ꯑꯗꯨꯕꯨ ꯑꯦꯅꯤꯋꯦ ꯆꯦꯛ ꯇꯧꯔꯒ ꯌꯦꯡꯁꯤꯀꯣ ꯑꯩ ꯍꯥꯏꯁꯦ ꯈꯪꯕ꯭ꯔꯣ ꯈꯪꯗꯕ꯭ꯔꯣ ꯃꯥꯅ ꯑꯣꯞꯁꯟꯁꯤꯗ ꯅꯣꯏꯗ ꯀꯟꯐ꯭ꯌꯨꯖꯤꯡ ꯆꯠꯅꯕ ꯄꯤꯔꯦꯕ ꯌꯦꯡꯉꯁꯤ ꯑꯍꯥꯟꯕꯗ ꯀꯃꯥꯏꯅ ꯄꯤꯔꯝꯃꯤ ꯑꯦꯒ ꯄꯤꯒ ꯑꯦꯁꯦ ꯄꯤ ꯑꯦꯟ ꯑꯦꯁ ꯑꯅꯤ ꯑꯅꯤ ꯄꯤꯕ꯭ꯔꯥ ꯑꯅꯤ ꯑꯅꯤ ꯄꯤꯔꯗꯤ ꯌꯥꯝ ꯂꯥꯏꯈ꯭ꯔꯦꯅꯦ ꯑꯅꯤꯅꯤ ꯄꯤꯔꯗꯤ ꯑꯅꯤꯅꯤ ꯑꯗꯨꯝ ꯈꯣꯠꯄꯤꯔ ꯂꯣꯏꯔꯦꯅꯦ ꯌꯥꯕ꯭ꯔꯥ ꯑꯗꯨꯗꯤ ꯁꯤꯗ ꯌꯦꯡꯉꯣ ꯑꯍꯥꯟꯕ ꯑꯦꯒꯤ ꯃꯥꯏꯅꯁ ꯇꯨ ꯅꯠꯇ꯭ꯔꯥ ꯃꯥꯏꯅꯁ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯌꯥꯕ꯭ꯔꯥ ꯌꯥꯗꯕ꯭ꯔꯥ ꯑꯗꯨꯒ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖꯄꯨ ꯍꯦꯛ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯀꯩ ꯑꯣꯏꯒꯅꯤ ꯁꯦ ꯀꯟꯀꯦꯞ ꯃꯤꯔꯔ ꯑꯃ ꯇꯥꯒꯗ꯭ꯔꯥ ꯇꯥꯔꯣꯏꯗ꯭ꯔꯥ ꯌꯥꯔꯦ ꯑꯗꯨꯗꯤ ꯑꯦꯒꯤꯗꯤ ꯑꯥꯔꯒ ꯀ꯭ꯌꯨꯒ ꯑꯦꯒꯤꯗꯤ ꯑꯥꯔꯒ ꯀ꯭ꯌꯨꯒꯗꯤ ꯀꯅꯥ ꯑꯣꯏꯕ ꯇꯥꯔꯦ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ ꯑꯦꯒ ꯕꯤꯒꯁꯤ ꯀꯦꯟꯁꯦꯜ ꯆꯠꯈꯤꯕ ꯌꯥꯕ꯭ꯔꯥ ꯑꯩ ꯍꯥꯏꯁꯤ ꯈꯪꯍꯧꯕ꯭ꯔꯥ
ꯈꯪꯉꯦ ꯁꯦ
ꯃꯤꯃꯤ ꯈꯪꯕ꯭ꯔꯕ ꯑꯩ ꯍꯥꯏꯁꯦ
ꯑꯥ ꯈꯪꯉꯦ ꯁꯦ
ꯍꯥꯏꯕꯗꯤ ꯑꯗꯨꯏꯗꯤ ꯁꯤꯗ ꯑꯦꯒꯤꯗꯗꯤ ꯃꯥꯅ ꯍꯥꯏꯁꯦ ꯀ꯭ꯌꯨꯒ ꯑꯥꯔꯒ ꯍꯥꯏꯕꯅꯦꯕ ꯀ꯭ꯌꯨꯒ ꯑꯥꯔꯒ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ ꯗꯤꯁꯨ ꯀꯦꯟꯁꯦꯜ ꯆꯠꯈꯤꯗ꯭ꯔꯥ ꯆꯠꯂꯣꯏꯗ꯭ꯔꯥ ꯑꯗꯨꯗꯤ ꯁꯨꯡꯍꯣꯠ ꯍꯣꯠꯇꯕꯤꯗ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ ꯁꯤꯁꯦ ꯑꯟꯁꯔ ꯇꯥꯒꯗ꯭ꯔꯥ ꯑꯃꯈꯛ ꯇꯧꯔꯒꯁꯨ ꯇꯥꯕ ꯌꯥꯕ꯭ꯔꯕ ꯁꯤꯅꯤ ꯅꯣꯏꯒꯤ ꯇꯦꯛꯇꯤꯛꯁ ꯇꯧꯒꯗꯕꯁꯦ ꯅꯣꯏꯅ ꯇꯦꯛꯇꯤꯛꯁꯇ ꯍꯩꯒꯗꯕꯁꯦ ꯑꯗꯨ ꯑꯦꯅꯤꯋꯦ ꯑꯩꯈꯣꯏ ꯌꯦꯡꯁꯤꯀꯣ ꯑꯇꯩꯁꯨ ꯆꯦꯛ ꯇꯧꯁꯤ ꯅꯦꯛꯁꯇ ꯑꯃꯨꯛ ꯀꯅꯥ ꯂꯩꯍꯧꯔꯤ ꯃꯥꯏꯅꯁ ꯍꯥꯞ ꯑꯃ ꯂꯥꯛꯄ ꯅꯠꯇ꯭ꯔꯥ ꯃꯥꯏꯅꯁ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯃꯁꯤ ꯀꯩ ꯑꯣꯏꯒꯅꯤ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯇꯥꯒꯗ꯭ꯔꯥ ꯇꯥꯔꯣꯏꯗ꯭ꯔꯥ ꯇꯥꯔꯅꯤ ꯍꯥꯞ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯄꯤꯛꯊꯔꯛꯑꯦ ꯄꯤꯛꯊꯕ ꯇꯥꯔꯗꯤ ꯔꯤꯌꯦꯜ ꯏꯃꯦꯖ ꯄꯦꯛ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯁꯤ ꯀꯩ ꯇꯥꯔꯅꯤ ꯗꯤꯁ ꯏꯁ ꯑꯣꯜꯁꯣ ꯀꯟꯀꯦꯞ ꯃꯤꯔꯔ ꯇꯥꯒꯗ꯭ꯔꯥ ꯇꯥꯔꯣꯏꯗ꯭ꯔꯥ ꯑꯗꯨꯑꯣꯏꯗꯤ ꯅꯝꯕꯔ ꯕꯤꯁꯨ ꯑꯗꯨꯝ ꯆꯨꯝꯃꯕ꯭ꯔꯥ ꯆꯨꯝꯃꯦ ꯌꯥꯔꯦꯀꯣ ꯒ꯭ꯌꯥꯟ ꯇꯥꯍꯧꯋꯤꯀꯣ ꯑꯩ ꯍꯥꯏꯔꯤꯁꯦ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯗꯤ ꯅꯦꯛꯁꯇ ꯑꯃꯨꯛ ꯌꯦꯡꯉꯣ ꯅꯝꯕꯔ ꯁꯤꯒꯤꯗ ꯀꯩꯅꯣ ꯁꯤꯒꯤꯗꯤ ꯄꯣꯖꯤꯇꯤꯞ ꯇꯨ ꯑꯃ ꯍꯥꯏꯕ ꯅꯠꯇ꯭ꯔꯥ ꯄꯣꯖꯤꯇꯤꯞ ꯇꯨ ꯑꯣꯏꯗꯤ ꯃꯥꯁꯦ ꯃꯦꯒꯅꯤꯐꯥꯏꯠ ꯑꯣꯏꯒꯗꯣꯏꯅꯦꯕ ꯆꯥꯎꯈꯠꯇꯣꯏꯅꯦꯕꯀꯣ ꯋꯥꯟꯗꯩꯕꯨ ꯍꯦꯛ ꯆꯥꯎꯈꯤ ꯇꯥꯔꯗꯤꯅꯦ ꯃꯥꯒꯤ ꯃꯦꯒꯅꯤꯐꯤꯀꯦꯁꯟ ꯚꯦꯂꯨꯁꯦ ꯋꯥꯟꯗꯩꯕꯨ ꯍꯦꯛꯅ ꯒ꯭ꯔꯦꯇꯔ ꯗꯦꯟ ꯑꯣꯏꯕ ꯇꯥꯔꯗꯤ ꯏꯠ ꯋꯤꯜ ꯕꯤ ꯃꯦꯒꯅꯤꯐꯥꯏꯠ ꯗꯣꯟ ꯐꯣꯔꯒꯦꯠ ꯗꯤꯁ ꯑꯦꯟ ꯃꯦꯒꯅꯤꯐꯥꯏꯠ ꯚꯔꯆꯨꯋꯦꯜ ꯏꯃꯦꯖ ꯋꯤꯜ ꯕꯤ ꯐꯣꯔꯝ ꯑꯣꯡꯂꯤ ꯕꯥꯏ ꯀꯅꯥ ꯑꯣꯏꯒꯗꯣꯏꯅꯣ ꯀꯟꯀꯦꯞ ꯃꯤꯔꯔ ꯀꯟꯀꯦꯞ ꯃꯤꯔꯔꯁꯤꯅ ꯈꯛ ꯐꯣꯔꯝ ꯇꯧꯗꯣꯏ ꯅꯠꯇ꯭ꯔꯣ ꯑꯦꯟ ꯏꯠ ꯋꯤꯜ ꯕꯤ ꯚꯔꯆꯨꯋꯦꯜ ꯑꯣꯏꯒꯅꯤ ꯕꯤꯀꯣꯁ ꯑꯣꯐ ꯄ꯭ꯂꯁ ꯑꯣꯏꯕꯒꯤ ꯑꯗꯨꯗꯤ ꯀ꯭ꯌꯨ ꯑꯦꯟ ꯑꯦꯁ ꯆꯨꯝꯃꯕ꯭ꯔꯥ ꯆꯨꯝꯃꯦ ꯗꯤꯒꯤꯗꯗꯤ ꯑꯃꯨꯛ ꯀꯩ ꯂꯩꯔꯦ ꯁꯤꯒꯤꯅ ꯅꯪꯒꯤ ꯄ꯭ꯂꯁ ꯐꯣꯔ ꯄ꯭ꯂꯁ ꯁꯥꯏꯟ ꯏꯠ ꯋꯤꯜ ꯕꯤ ꯚꯔꯆꯨꯋꯦꯜ ꯑꯦꯟ ꯐꯣꯔ ꯂꯦꯁ ꯗꯦꯟ ꯚꯦꯂꯨ ꯋꯥꯟ ꯂꯦꯁ ꯗꯦꯟ ꯚꯦꯂꯨ ꯑꯣꯏꯕꯒꯤ ꯅꯪꯒꯤ ꯀꯅꯥ ꯑꯣꯏꯒꯅꯤ ꯀꯟꯚꯦꯛꯁ ꯃꯤꯔꯔ ꯑꯗꯨ ꯄꯤ ꯑꯦꯟ ꯗ ꯑꯦꯁ ꯀꯔꯦꯛ ꯑꯣꯏꯔꯕ ꯑꯣꯏꯔꯦ ꯑꯗꯨꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯋꯤꯗꯥꯎꯠ ꯑꯦꯅꯤ ꯀꯥꯜꯀꯨꯂꯦꯁꯟꯗ ꯐꯥꯔꯁ ꯑꯣꯞꯁꯟꯁꯤ ꯌꯦꯡꯉꯒ ꯑꯟꯁꯔ ꯇꯥꯈꯤꯕ ꯌꯥꯕ꯭ꯔꯥ ꯌꯥꯗꯕ꯭ꯔꯥ ꯏꯂꯤꯃꯤꯅꯦꯁꯟ ꯇꯧꯔꯒ ꯑꯗꯨ ꯅꯣꯏꯅ ꯂꯣꯏꯅ ꯈꯪꯕꯩ ꯃꯊꯧ ꯇꯥꯗꯦꯕ ꯖꯁ ꯋꯥꯟ ꯑꯣꯞꯁꯟ ꯁꯦꯂꯦꯛ ꯇꯧꯔꯣ ꯀꯣꯏꯁꯟ ꯑꯟꯁꯔꯁꯨ ꯇꯧꯔꯣ ꯑꯗꯨꯒ ꯏꯂꯤꯃꯤꯅꯦꯠ ꯇꯧꯔꯣ ꯍꯩꯒꯗ꯭ꯔꯥ ꯍꯩꯔꯅꯤ ꯍꯌꯦꯡ ꯃꯈꯥꯉꯩꯁꯤꯗ ꯍꯌꯦꯡ ꯍꯣꯜꯂꯁꯤꯀꯣ ꯅꯝꯕꯔ ꯐꯣꯔ ꯅꯝꯕꯔ ꯐꯥꯏꯚ ꯅꯝꯕꯔ ꯁꯤꯛꯁ ꯀꯁꯤ ꯑꯩ ꯍꯌꯦꯡ ꯑꯣꯜꯂꯁꯤ ꯍꯧꯖꯤꯛꯀꯤ ꯑꯣꯏꯅ ꯂꯣꯏꯁꯤꯜꯂꯁꯤꯀꯣ